Edge of reality. 8 unbelievable cosmic anomalies. Welcome to the edge of reality, the place where science fiction shakes hands with hard physics, the twilight zone of the cosmos. Buckle up, because what you're about to hear is not fiction. It's the universe, unfiltered and unapologetically weird. Let's begin with the Buddha's Void, a region of space so empty, so devoid of matter, it might as well be the universe's ultimate no man's land. Stretching over 300 million light-years across, it's not just a gap between galaxies. It's a yawning cosmic silence, like a place where the universe forgot to build. We're talking about a region with 10% of the average galaxy density. If you traveled through it at the speed of light, it would still take you 300 million years to find a decent star. Scientists don't know if it's a result of primordial fluctuations or some hidden exotic physics. But whatever it is, it's not just empty space. It's an abyss, and it laughs in the face of everything we think we know about the uniformity of the cosmos. Now swing your telescope toward quasars, those luminous monsters lurking at the edge of the visible universe. They shine brighter than 1 trillion stars, powered by nothing more than matter falling into a black hole. But not just any black hole, a supermassive one. And here's the kicker. Some of these quasars existed just a few 100 million years after the Big Bang. How did these beasts grow so fast, so early? It's like finding a fully grown T-Rex still fresh from the egg. We don't know how they did it, but they did. And they're still out there, whispering secrets from the dawn of time. Then there's dark flow, a mysterious, one-directional motion of galaxy clusters that seems to defy the expansion of the universe itself. Picture galaxies racing off in the same direction, like cosmic marathoners drawn towards some unseen finish line. What are they chasing? Or better yet, what's pulling them? Some speculate it's a signal from a parallel universe, leaking through the seams of space-time. If true, it would mean that our universe isn't the only one. It's just one bubble in a vast, multiversal ocean. And dark flow, that might be the rippling current between them. Speaking of things that shouldn't exist, enter the realm of negative mass. Yes, negative mass. Imagine pushing something and it accelerates towards you. That's not a thought experiment. That's a mathematical solution to Einstein's field equations. It flips Newton's laws inside out. In theory, if negative mass existed, it could create exotic phenomena like warp drives or stable wormholes. So far, we haven't found any, but theoretical physicists keep poking at the math, because sometimes the universe doesn't just bend the rules, it rewrites them in invisible ink. And what about fast radio bursts? Those millisecond-long blips of radio waves from galaxies billions of light-years away. At first, we thought they were anomalies, glitches in our detectors, but they kept happening. Random, powerful, and totally unexplained. Some repeat, some don't, some follow a pattern. Others appear to be completely chaotic. We've ruled out cell towers and satellites. What remains is one of the most confounding mysteries in astronomy. Are they from magnetars, collapsing neutron stars? Or are we eavesdropping on an alien civilization, pinging us from across the void? Now brace yourself for the galaxy without dark matter. That's like discovering a car engine that runs without gasoline. Scientists found this galaxy, NGC 1052-DF2, that behaves as if dark matter, that invisible scaffolding believed to hold galaxies together, simply doesn't exist. Its stars orbit so slowly, there's no need for dark matter to explain their motion. Could this be a fluke? or a hint that our theories of gravity and matter are still missing a crucial piece. Whatever it is, it challenges the very foundation of modern cosmology. Let's dive into something wilder. The cold spot in the cosmic microwave background, a huge, anomalously cool region of the sky. Some scientists believe it might be the imprint of a massive void. Others suspect it's a leftover fingerprint from a collision between universes in the early moments after the Big Bang. A cosmic bruise, if you will, where our universe bumped into another bubble universe in the multiverse foam. That's right, this anomaly could be physical evidence that we are not alone, not just in space, but in realities. And finally, we arrive at the most mind-bending anomaly of them all: quantum entanglement. Two particles, separated by billions of miles, influence one another instantly. No signal, no delay. Einstein called it spooky action at a distance because it violates everything we understand about locality and causality. And yet, it's real, proven, verified, used in experiments again and again. It tells us that the universe is not a collection of isolated objects, but a deeply interconnected whole. Reality, it turns out, might be woven from invisible threads of quantum code, entangled, enmeshed, and fundamentally indivisible. So what do all these anomalies mean? Maybe the universe isn't just stranger than we imagine, it's stranger than we can imagine. These oddities aren't just footnotes in textbooks, they're signposts, clues, invitations to keep asking questions. Because every time the cosmos shows us something impossible, it's really just showing us the next step in discovering what's possible. Somewhere in the void between galaxies, there exists a place called El Gordo, a galactic collision so massive, so energetic, that it practically shatters the boundaries of what gravitational physics says is possible. Two gigantic clusters smashing into each other at breakneck speeds, producing a combined mass greater than theoretical models can comfortably explain. This isn't just a clash of stars, it's a full-blown cosmic demolition derby, and yet the physics doesn't add up. Simulations suggest such a high-speed impact shouldn't have happened in the lifetime of the universe. But El Gordo is there, real, radiating X-rays and warping space like some celestial behemoth. The only question is, how? Now pivot to something more intimate, yet no less bizarre. Rogue planets, homeless wanderers, ejected from their parent systems, drifting silently through interstellar space. No sun, no orbit, no day or night, just eternal blackness. And yet some of these loners are as massive as Jupiter, possibly even surrounded by moons or faint rings, carrying the memory of a system they once belonged to. How many are out there? Trillions, perhaps. The galaxy might be more full of planet orphans than stars, a silent majority that defies everything we thought we knew about planetary formation. But not all anomalies are about size. Some are about rhythm. Enter the Tabby star Enigma, a sun-like star dimming and flickering in a way no planet dust cloud or asteroid field can explain. Its brightness drops irregularly, sometimes by 22%, which is staggering. Stars don't just do that. Natural explanations range from swarms of comets to planetary debris, but the mystery remains. It even spawned hypotheses involving megastructures like Dyson spheres, built by alien civilizations harvesting stellar energy. Is it far-fetched? Sure, but in the absence of solid answers, even the wildest ideas remain on the table. Then there's the curious case of ultra-diffuse galaxies. These ghostly structures are the phantoms of the universe, so faint you could stare right through them. Some are as big as the Milky Way, but contain only a fraction of the stars. Others seem to be made entirely of dark matter, while a few appear to be almost entirely free of it. Like celestial jellyfish drifting in the galactic deep sea, they refuse to fit into existing categories. Where did they come from? Did they form normally and get stripped of their stars, or are they relics of some forgotten epoch? Now let's flip the scale again to Planck units, a realm so fundamental that space, time, and even logic start to unravel. Below the Planck length, our entire concept of distance ceases to have meaning. Below the Planck time, causality becomes a suggestion rather than a law. You can't observe, measure, or interact with anything on these scales because the tools we have and the universe itself might not operate down there at all. It's the ultimate do not enter sign of reality, guarding the secrets of quantum gravity with a shrug and a smirk. And just when you think it couldn't get weirder, you learn about white holes. The theoretical opposites of black holes, they don't suck matter in, they spit it out. Permanently sealed from the inside, they reject anything that tries to cross their boundaries. A white hole could be the other end of a black hole's tunnel, creating a cosmic recycling system that spans both space and time. We've never observed one, but their existence is mathematically permissible. Some theories even suggest that the Big Bang itself might have been a white hole event, an explosion, not from nothing, but from something else entirely. Let's not forget axions, hypothetical particles so light, so ghostly, that trillions could pass through you every second without ever leaving a trace. They might solve the mystery of dark matter. They might explain why our universe prefers matter over antimatter, and they might be lurking in the background of existence, shaping galaxies while hiding in plain sight. Finding them would revolutionize physics overnight. Not finding them might mean our theories are still embarrassingly incomplete. Finally, look toward the most volatile, unpredictable stars in the cosmos, magnetars. Born from the death throes of massive stars, these ultra-dense neutron stars wield magnetic fields a quadrillion times stronger than Earth's. A magnetar's surface is a nightmare, solid iron crust, cracking under magnetic tension, unleashing gamma-ray flares that can fry satellites and ripple through space-time. One such burst, in 2004, originated 50,000 light-years away, and it still disrupted Earth's upper atmosphere. If one of these monsters went off in our stellar neighborhood, it could sterilize a planet in seconds, yet they remain brief, furious, and utterly alien. Welcome to Whispers of the Cosmos, fellow cosmic adventurers. Today, we're embarking on an exhilarating journey to uncover stars that defy the very rules that astrophysicists have carefully crafted. Get ready to be astonished, mystified, and inspired as we count down the top 7 stars that shouldn't exist, yet somehow do, baffling the sharpest minds and rewriting our cosmic rulebooks. Buckle up, my friends. It's time to meet the universe's greatest stellar rule breakers. Let's start our voyage with something truly extraordinary. Contact binary stars, or as I affectionately call them, the clingiest couples in the cosmos. Picture 2 massive stars orbiting each other so tightly that their surfaces literally merge into a peanut-shaped star. These stellar siblings violate the very fabric of gravitational balance. Physics tells us that stars this close should either spiral into a catastrophic collision or violently fling each other apart, but not these celestial twins. Instead, they exist in a delicate, mesmerizing dance, sharing their outer atmospheres, exchanging gas, and spinning faster and faster. This bizarre gravitational embrace creates immense energy and dazzling brightness, stunning astronomers, and forcing us to reconsider the rules of stellar evolution. Next, we travel far back in time, nearly 13 billion years ago, to the colossal, mysterious, and long-extinct population 3 stars, the first true giants of the cosmos. Imagine stars so massive, hundreds of times heavier than our Sun, blazing at millions of degrees and burning with pure primordial hydrogen and helium. Scientists say stars like these shouldn't have existed at all because their immense gravity should have made them unstable, exploding almost immediately. Yet they defied these constraints, igniting in a dark newborn universe and illuminating the cosmos for a fleeting moment. Their colossal deaths triggered a cosmic fireworks display, scattering the very first heavy elements like carbon, oxygen, and iron across the cosmos, planting the seeds for planets, life, and ultimately, you and me. Population 3 stars broke every rule we thought we knew about star formation, and they still echo through space as hauntingly beautiful cosmic legends. Now, get ready for the incredible, perplexing, and scalding hot, ultra-hot dwarf stars. Picture a star barely larger than Jupiter, yet glowing intensely at over 100,000 degrees Fahrenheit. According to stellar physics, dwarf stars shouldn't sustain temperatures this extreme. They're supposed to be mild-mannered, slow-burning balls of gas. Yet these miniature furnaces blaze fiercely, spewing intense ultraviolet radiation into space. Astronomers speculate these stellar oddballs could be remnants of older, larger stars stripped down to their fiery cores. Or perhaps they're survivors of violent stellar collisions. No matter their origin, they mock the textbooks and demand we rethink the life cycle of stars. Coming up next, we meet cosmic rogues known affectionately as blue stragglers, stars that defy aging itself. Imagine stars within dense stellar clusters, glowing brighter, hotter, and younger-looking than their similarly aged neighbors. It's like walking into a retirement home and finding someone sprinting on a treadmill, effortlessly outrunning their age. How do these stellar misfits maintain such youthful vigor? It seems they've found a fountain of youth by stealing mass from companion stars, cannibalizing their neighbors, or merging dramatically in celestial collisions. These rebellious stars refuse to follow the typical aging process, bewildering astronomers and hinting that star clusters hide countless secrets we've yet to fully unravel. Let's now explore the bizarre phenomenon of stars with forbidden elements. Imagine detecting elements like technetium in the atmospheres of red giants, elements so unstable they decay rapidly and should vanish quickly from the star's surface. Yet here they are, stubbornly present, boldly defying our understanding of nuclear chemistry. These cosmic chemists seem to have figured out how to continuously replenish elements that ought to vanish almost instantly. Scientists are still puzzled. Do these stars harbor strange nuclear processes, or are there hidden currents deep beneath their surfaces that continuously resupply these mysterious elements? Whatever their secret, they openly challenge the laws of physics and chemistry, daring astronomers to dig deeper into their cosmic mysteries. Next up, brace yourselves for the unpredictable, dazzling enigma of variable stars with anomalous pulsations. Imagine stellar beacons that pulse like cosmic lighthouses, but with heartbeats so irregular and erratic they defy prediction. Typically, pulsating stars have steady rhythms, like reliable cosmic clocks that astronomers use to measure distances across galaxies. But these anomalous pulsators break the mold completely, fluctuating wildly in brightness and intensity with no clear pattern. Some pulse too quickly, some slow down unpredictably, and others shift rhythm without warning. Are these stars hiding secret instabilities deep within their cores, or perhaps mysterious magnetic fields that twist and disrupt their pulsations? Whatever the cause, these stars have astronomers revisiting their textbooks, scratching their heads, and questioning the very nature of stellar physics. Finally, let's journey to the extraordinary and visually stunning carbon giant stars. Stars so enriched in carbon they resemble colossal rubies suspended in the void. These massive red giants astonish us by flaunting an abundance of carbon that defies our standard stellar models. Stars usually fuse hydrogen into helium, then helium into carbon and oxygen, but typically never accumulate vast amounts of pure carbon. Yet these cosmic jewel factories not only produce it, they overflow with it, spreading carbon dust into interstellar space. This cosmic carbon dust eventually seeds planets and moons, even paving the way for life itself. These carbon giants, shining red and rich, tell us the universe has more surprises, more intricate chemical pathways, and greater complexity than our current theories can fully grasp. Each of these remarkable stars pushes our scientific boundaries, taunting astronomers with riddles of physics, chemistry, and cosmic evolution. They remind us vividly of something crucial. Our understanding of the universe isn't static. It evolves, deepens, and enriches with every cosmic mystery solved or discovered. These stellar rebels challenge us, inspire us, and continually invite us onward, deeper into the spectacular and ever-surprising heart of our cosmos. In the end, these cosmic anomalies, the rebels, the rule breakers, the impossible stars, aren't just astronomical oddities. They're powerful reminders of how much we still have to discover, how many secrets the universe still holds close. Every time we think we've finally grasped the cosmos, it whispers back to us, think again. These stellar enigmas invite us to explore, to question, and to wonder endlessly. After all, the greatest adventure in science isn't just in finding answers, it's in uncovering new questions we never knew existed. Keep looking up and stay curious. Chuang Ti Ding Duan. When you think about speed, maybe you imagine a race car, a fighter jet, or even a rocket ripping through Earth's atmosphere. But out there, beyond our tiny blue planet, the cosmos has a whole different idea of speed, a level so extreme it shatters the imagination. Today, we dive headfirst into the most bizarre objects spinning at speeds that make the wildest roller coaster seem like a lazy Sunday drive. Imagine an object no bigger than a city, spinning so fast that if you stood on its surface, you'd be launched into space faster than you could blink. That's the reality of a neutron star, the crushed corpse of a once massive star. When a star dies in a supernova explosion, if the conditions are just right, its core collapses into a sphere so dense it defies our understanding of matter. Some neutron stars, known as millisecond pulsars, rotate hundreds of times per second, 700, even 800 revolutions every tick of the clock. That's faster than the blades of a helicopter, faster than a bullet speeding from a gun. The forces at play are so fierce that the star's crust, an iron shell thicker than Mount Everest is tall, literally cracks and quakes under the strain. But if you think that's crazy, buckle up. There's a particular pulsar out there named PSRJ 1748-2446 AD, the fastest spinning neutron star ever discovered. It rotates at an insane 716 times per second. That's nearly a quarter the speed of light at its equator. If it spun just a little faster, it would tear itself apart. Nature, it seems, loves to live on the edge. And what about white dwarfs? These smoldering, planetary-sized remnants of dead stars are usually calm. But not always. Some white dwarfs spin at blistering speeds, completing a full rotation every few minutes. That's like an object the size of Earth spinning so fast that an entire day lasts less than the time it takes to heat your coffee. These compact beasts maintain incredible rotational energy, trapped in a silent, frozen ballet that's been dancing for billions of years. Now zoom out even further, beyond stars, beyond planets, to the chaotic hearts of galaxies. Supermassive black holes, monsters millions or even billions of times the mass of our Sun, don't just sit there quietly. Some of them spin at near light speed. Picture a singularity, a point of infinite density, wrapped in a whirling maelstrom of space-time itself. At these speeds, the very structure of reality bends around the black hole, twisting magnetic fields, warping space, dragging entire star systems into violent, incandescent orbits. The most extreme among them spin so fast that if you were unlucky enough to fall in, you wouldn't just be swallowed, you'd be twisted and mangled across dimensions as you disappeared into oblivion. But not everything spinning insanely fast has to be massive. In the cosmic junkyard of the solar system, tiny asteroids are doing pirouettes faster than any Olympic figure skater. Some, like asteroid 2008 HJ, rotate completely in under 30 seconds. Imagine a rock hurtling through space, barely 12 meters wide, yet spinning so fast that its surface speeds exceed hundreds of kilometers per hour. If it were made of anything less dense than solid rock, it would disintegrate into a cloud of dust. It's a cosmic tightrope act, with gravity and momentum locked in a perpetual daredevil's handshake. And then there are stars like VFTS 102, a massive blue giant tearing through its rotation at over 2 million kilometers per hour at its equator. That's so fast, its entire structure bulges outward, stretched into an oblate spheroid by centrifugal forces. This is a star, barely holding itself together, living every second on the razor's edge, between cohesion and collapse. It's not just burning hydrogen, it's burning through the limits of physics itself. Finally, let's talk about something you wouldn't expect to make the list: planets. Take Jupiter, for example. Despite its titanic size, a planet so large it could fit over 1,300 Earths inside, Jupiter spins faster than any other planet in the solar system. A single day on Jupiter lasts just about 10 Earth hours. That's like spinning a skyscraper-sized ball of gas and storms at breakneck speed without it flying apart. And it's no gentle whirl either. This rapid rotation powers Jupiter's monstrous storms. Storms so big they could swallow Earth whole, fueled by a spin that just won't quit. In the grand theater of the universe, speed is a currency, and the cosmos spends it with reckless abandon. In neutron stars whirling like cosmic blenders, in asteroids dancing at the edge of destruction, in black holes that twirl space-time into knots. Speed isn't just about motion. It's about the violence, the power, and the sheer unstoppable momentum written into the DNA of the universe itself. But the universe doesn't stop at spinning stars, collapsing cores, and rampaging asteroids. It gets even stranger. It gets wilder. Some objects aren't just spinning fast, they're spinning in ways that defy every rulebook we thought we understood. Take spinning quark stars, theoretical objects even denser than neutron stars. If they exist, they could spin even faster, their surfaces moving at a terrifying fraction of light speed. Inside, the very matter is crushed beyond atoms, into a soup of quarks, the building blocks of protons and neutrons. Imagine an object no bigger than a city, spinning so viciously that space-time itself ripples around it like water around a whirlpool. It's a cosmic blender, operating at speeds and densities where physics itself begins to lose meaning. Or picture the fastest spinning brown dwarfs, objects too big to be planets, too small to ignite as stars. Some of these cosmic misfits complete a rotation in just a few hours. They spin so fast that their equators bulge outward, like cosmic belly dancers, puffed up by centrifugal force, defying the smooth, serene faces we associate with stars and planets. These are failed stars partying like it's the end of the universe, flaunting their speed for all of creation to see. Even closer to home, Earth isn't immune to bizarre spin phenomena. Our planet doesn't rotate at a perfectly constant rate. Tiny changes, gravitational tugs from the moon, mass movements of the atmosphere and oceans, cause Earth's spin to wobble, to speed up, to slow down. Earth is engaged in a slow cosmic dance, its spin subtly swaying with the invisible currents of the solar system. It's a reminder that even something as familiar as one day is really a delicate balancing act on a cosmic stage. Then, there are entire galaxies that spin like titanic pinwheels in the night. Take the Cartwheel Galaxy, whose perfect, eerie shape was sculpted by a collision with another galaxy millions of years ago. Its outer ring is spinning outward, pushing through space like a shockwave frozen in time. Entire solar systems are riding that wave, hurled forward by the echoes of a galactic impact, moving through space at speeds beyond imagination. Or consider ultra-fast magnetars, neutron stars born not just spinning fast, but magnetized to the extreme. Their magnetic fields are so powerful, they can slow their insane spin down dramatically within just a few thousand years, blasting energy into the cosmos like galactic lighthouses gone berserk. At birth, they spin so fast, perhaps over 1,000 times per second, that the energy released could outshine an entire galaxy for brief, searing moments. These are cosmic firecrackers, burning bright and dying young, leaving behind ghostly remnants whispering through the void. And while we're at it, let's not forget the accretion disks around young stars. These spinning maelstroms of gas and dust aren't just picturesque. They're high-energy factories where new planets are forged. These disks rotate at staggering speeds, with material moving faster than the speed of sound in gas. Every inch of these swirling disks is a chaotic battle of gravity, pressure, and turbulence, a frantic, furious dance where worlds are born in violence. The universe doesn't just spin, it pirouettes, it whirls, it howls through the endless night with energies and speeds that stretch the very fabric of space and time. Every spinning object out there, from tiny asteroids to monstrous black holes, is a reminder that motion is life, motion is violence, and motion is the heartbeat of the cosmos. The stars don't just burn, the planets don't just orbit, the galaxies don't just drift. They spin, they rage, they scream across the silent emptiness at speeds that mock our puny human understanding of motion. And just when you think the cosmic carousel couldn't spin any faster, quantum mechanics steps into the arena and completely rewrites the rules. At the smallest scales imaginable, particles like electrons and quarks exhibit a strange property called intrinsic spin. Not spin like a planet or a top, but an inborn angular momentum that defies everyday intuition. These fundamental particles are spinning metaphorically at impossible speeds, forever locked into a quantum twirl that underpins the very structure of reality. Without this ceaseless, invisible motion, atoms wouldn't hold together, chemistry wouldn't work, life itself wouldn't exist. Even entire clusters of galaxies, unimaginably vast collections of hundreds, even thousands of galaxies, have been caught in the act of rotating slowly over billions of years. Their spins are so colossal, so ancient, that they trace back to the earliest whispers of structure in the universe, seeded in the aftermath of the Big Bang. It's a cosmic inheritance of motion, a momentum handed down through eons, echoing across the darkness. Some theorists even speculate about exotic objects called gravis stars or boson stars, hypothetical entities that might spin in ways even more exotic than anything we've ever observed, combining extreme mass, rapid rotation, and quantum properties into a cocktail that pushes the very limits of known physics. If these objects exist, they could be the most bizarre and fastest spinning phenomena in all of creation, hidden out there, waiting for our instruments to catch up to their mystery. Rotation is the language of the universe's most extreme and most delicate creations alike, from collapsing giants to newborn stars, from tumbling asteroids to the quantum pirouettes of invisible particles. Spin is a fundamental, inescapable feature of existence. It powers magnetic fields that protect worlds. It sculpts solar systems. It unleashes jets of energy that stretch across millions of light years. In the end, spinning is not just what objects in space do. It's what space itself does. Every whirl and every twirl is a frozen signature of past violence, past creation, past change. The cosmos remembers its history in every turn, every rotation, every impossible spin we glimpse through our telescopes and instruments. It's a universe that never stands still, a universe forever in motion, forever alive. Here at Whispers of the Cosmos, we chase those secret motions, those hidden rotations, those cosmic pirouettes that define the very fabric of existence. Every spin, every pulse, every orbit is a whisper carried across the void, a message from the universe itself. And as long as there are mysteries whirling in the darkness, we'll be here, listening, exploring, and sharing their stories with you, one cosmic whisper at a time. We look up at the stars and see beauty, order, a cosmic dance of planets, galaxies, and light. But behind that serene facade lurk ideas so terrifying, so mind-bending, that they shake the foundations of everything we think we know. The universe isn't just vast, it's stranger, darker, and far more unsettling than we dare to imagine. Take the idea of heat death. One day, the universe might not end in fire, but in silence, a slow, freezing fade-out into nothingness. As stars burn out and galaxies drift apart, energy will spread thinner and thinner until there's no usable heat left, no motion, no life. Just a cold, empty void stretching forever. It's not a dramatic finale, it's a quiet, endless darkness where even time loses its meaning. But maybe we won't even make it that far. Vacuum decay could erase us long before the stars flicker out. If the universe exists in a false vacuum, a temporary unstable state, a tiny bubble of true vacuum could appear anywhere, at any moment. Expanding at the speed of light, it would annihilate everything it touches, rewriting the laws of physics in an instant. No warning, no escape, no trace. Reality as we know it, gone before you even realize it happened. And what about Boltzmann brains? According to some interpretations of thermodynamics, it's statistically more likely for a fully formed, conscious brain with false memories and perceptions to spontaneously pop into existence in the void than for the entire universe to form as we observe it. In other words, you might not be real. You could just be a fleeting thought in a sea of chaos, destined to blink out of existence as quickly as you appeared. Then there's the nightmarish concept of the Big Rip. As dark energy accelerates the expansion of the universe, it could eventually tear apart galaxies, then stars, then planets, and finally, the very atoms themselves. First, the night sky would empty. Then, solar systems would unravel. Finally, as the end approached, even the molecules of your body would be shredded by a force no shield could withstand, a cosmic unraveling, atom by atom at the speed of inevitability. But maybe it's worse than that. Maybe the universe is cyclic, endlessly repeating itself. Big bangs followed by big crunches, rebirths followed by destruction, over and over for all eternity. Every life you live, every memory, every moment of joy or despair, doomed to repeat endlessly, trapped in an infinite loop you can never break. Freedom, choice, meaning, illusions, forever reset at the closing of each cosmic cycle. And then there's the bleak suggestion that we might be living inside a simulation. Maybe none of this is real. Maybe some ancient godlike civilization created our universe as a playground, a science experiment, or a forgotten relic of their history. Everything you've ever loved, every triumph, every sorrow, mere lines of code running in a cosmic computer you'll never see, operated by beings you'll never understand. Even more unsettling is the idea that the universe is hostile by design. Maybe intelligence is doomed by the very laws of nature. Maybe the conditions for life are so rare, so fragile, that civilizations everywhere flicker out before they can reach the stars, snuffed out by their own technology, cosmic disasters, or simply the cold indifference of a universe that doesn't care. And what if the darkness we see between galaxies isn't empty at all? Some theories suggest the existence of dark flow, a mysterious, massive movement of galaxy clusters towards an unseen, unknown region of space. Something out there might be pulling at our universe with gravitational fingers we can't detect or comprehend. A force older than the Big Bang, lurking beyond the edge of everything we know. Then there's the idea that the universe has no bottom, that no matter how deep you go, there's always another level of structure, another layer of reality. Quarks, strings, quantum foam. What if there's no end to the rabbit hole? What if we are forever trapped in an infinite descent into smaller and smaller scales, with no hope of ever reaching bedrock? A universe of endless mystery, forever just out of reach. And finally, the ultimate terror. We are completely alone. No ancient civilizations sending signals, no distant worlds brimming with alien life. Just one tiny planet, orbiting an average star, in a forgotten corner of an ordinary galaxy, utterly isolated in an unimaginably vast emptiness. If that's true, then the universe isn't just indifferent to our existence. It's silent, and we are the only witnesses to its infinite beauty, its infinite indifference. The universe is not just a place of wonder. It is a place of profound, almost unbearable strangeness. And every time we peel back a layer, we find not comfort, but deeper mystery, staring back at us through the abyss. And as if the terror of existential isolation weren't enough, some scientists propose the idea of a multiverse, a limitless sea of universes, each with different laws of physics, different constants, different fates. In one, gravity might be too weak for stars to form. In another, atoms might not even exist. And if infinite universes truly exist, then there are infinite versions of you. Some living wildly different lives, others perishing in worlds too hostile for anything recognizable. Every choice, every chance, every horror played out somewhere across the endless tapestry of existence. But not all multiverses are gentle. Bubble universes could be expanding within this cosmic foam, and if one of these bubbles, governed by different physical laws, collided with ours, the result would be catastrophic. Like a cosmic tsunami, its frontier would obliterate everything in its path at nearly the speed of light, rewriting the very foundations of reality as it passes. No warning, no defense, just a wall of unstoppable change rolling across the heavens. Another unsettling idea: the observable universe is just the smallest sliver of the true cosmos. What we can see, all the galaxies, stars, and nebulae, could be just a tiny island in an infinite ocean. Beyond our visible horizon, endless realms may stretch on forever, utterly unreachable, forever hidden from us by the limits of light and time. And out there, the laws of physics might not just be different. They might be lethal to anything like us. And then there's the terrifying possibility of cosmic string catastrophes. These hypothetical defects in space-time, thinner than an atom, yet heavier than a mountain range, could whip through the cosmos at near-light speeds. If one passed through our solar system, it could slice planets in half like a cosmic scalpel. Earth, in the blink of an eye, could be split into two incandescent halves, reduced to molten debris spiraling into the void. Another mind-bending theory warns of time being an illusion, that our sense of past, present, and future is a trick of consciousness. In reality, all moments might exist simultaneously, stacked like pages in a book. You aren't moving through time. You are simply experiencing one page at a time. Your birth, your death, the death of the stars, all already written, immutable, unavoidable. And if you think black holes are terrifying simply because they devour everything in their path, brace yourself for the idea of black hole cosmology. Some theorists suggest that every black hole might spawn an entirely new universe inside it. That means inside each black hole's event horizon, untold billions of new cosmoses might be unfolding, completely cut off from our own, each one birthing stars, galaxies, maybe even life. And if that's true, our own universe might be the inside of some other cosmic black hole, born in the violent death of a parent universe we will never know. And while we're talking about dark ideas, we can't ignore phantom energy, an even more aggressive form of dark energy that doesn't just accelerate the expansion of the universe. It accelerates it faster and faster over time. In such a scenario, galaxies would be torn apart, stars shredded, planets ripped to atoms, and even the very fabric of space itself would be pulled apart. Space wouldn't just expand, it would stretch until it shattered. The chilling reality is that most of the universe is invisible to us. Dark matter and dark energy, two of the greatest mysteries in modern physics, make up over 95% of everything, yet we cannot see them, touch them, or fully understand them. We are shadows living in the glow of an invisible, dominant cosmos. Whatever dark matter is, it's all around us, passing through us, woven into the very architecture of existence. And we don't even know if it's benign. And if that doesn't rattle your sense of security, consider the idea that causality itself could break down. In some extreme gravitational environments, like near the heart of spinning black holes, the normal flow of cause and effect could collapse. Events might happen out of order. Effects could precede causes. Reality itself could become a hall of mirrors where logic, reason, and sequence are abandoned. A cosmic madhouse where nothing you rely on to understand the world would hold true. The deeper we gaze into the abyss of the cosmos, the clearer it becomes. The universe is not here to comfort us. It is vast, it is indifferent, and it harbors secrets far more terrifying than any nightmare the human mind can conjure. Yet still, we reach outward, daring to ask questions whose answers might forever change how we see ourselves and everything around us. And just when you think you've wrapped your mind around these terrifying ideas, the universe pulls back another curtain. Some physicists propose the unsettling notion of quantum immortality. According to certain interpretations of quantum mechanics, every time a potentially fatal event happens, the universe splits. In one branch, you perish, but in another, you survive. From your own perspective, you never die. You keep waking up in a world where you somehow escaped fate, no matter how improbable. But the cost? Endless universes where countless versions of you meet countless inevitable ends. A multiverse cemetery sprawling beyond comprehension. Another chilling speculation is the idea of information loss in black holes. If true, it means that when something falls into a black hole, not just its atoms, but its information, the very blueprint of its existence, is erased from the universe. This breaks one of the fundamental laws of physics, that information must be conserved. If black holes really do destroy information, then the universe itself becomes a place where history can be erased, memories lost, and meaning itself swallowed forever by the darkness. And lurking even deeper in the speculative shadows is the concept of the ultimate fate of intelligence. Some theorists believe that no matter how advanced a civilization becomes, it's doomed by the very structure of the cosmos. Entropy will always win. Stars will burn out. Energy supplies will dwindle. Eventually, even the most brilliant minds, the most resilient machines, the most enduring ideas will be snuffed out by the slow, creeping death of the universe itself. There's even a possibility that time might spontaneously reverse. Deep within the chaotic interplay of thermodynamics and quantum fluctuations, there could come a moment when the arrow of time flips, running backward. Cause would follow effect. Stars would unform. Civilizations would crumble into dust, and then the dust itself would reassemble into ancient worlds. It would be a cosmic rewind so alien, so profound, that existence as we know it would become a surreal, broken mirror of itself. Or consider the idea of false memories. The chilling thought that the universe could be so old, so vast, that entire civilizations might be engineered into existence with fabricated memories. You could have been born 5 minutes ago, implanted with every recollection, every scar, every dream, all of it illusions stitched into your mind by the random, merciless chaos of an infinite cosmos. And one of the ultimate cosmic horrors? Existence might not require consciousness at all. In the grand scheme, thinking beings could be a fluke, a temporary, unnecessary glitch in an otherwise mindless, mechanical unfolding of matter and energy. Intelligence, creativity, wonder, mere sparks against the dark, soon extinguished and forgotten by a universe that neither notices nor cares. The more we learn, the more we realize the universe isn't built for comfort. It isn't crafted for survival. It isn't tailored to our hopes, our dreams, or our desperate need for meaning. It simply is a cold, vast, indifferent reality where beauty and terror are inseparably intertwined. Every star that shines is a star destined to die. Every planet that forms is one meteor away from obliteration. Every life that blooms carries within it the seeds of its inevitable end. And yet, we explore, we question, we reach out into the dark. Here, at Whispers of the Cosmos, we lean into that darkness. We listen to the chilling secrets that the stars refuse to shout, but whisper instead. Quiet truths, woven into the fabric of existence. Every terrifying theory, every unimaginable mystery, every cosmic revelation reminds us that we are part of something far bigger, far stranger, and far more breathtaking than we ever dared believe. So we will keep asking, keep seeking, and keep listening to the universe, one whisper at a time.
Top 10 most extreme planets ever discovered. Our solar system is weird, no doubt about it. We've got a gas giant with 100 moons, a planet that spins sideways, and a rock where it rains sulfuric acid. But once you step outside our little planetary neighborhood and look at the rest of the galaxy, things get truly insane. Because out there, beyond the quiet familiarity of Earth and Mars, lie planets so extreme, so alien, so unimaginable, they shatter everything we thought planets could be. These aren't science fiction worlds. These are real, confirmed by telescopes, sensors, and good old-fashioned math. And they're rewriting the rules of what it means to be a planet. Take HD 189733b, for example. At first glance, it seems like a typical hot Jupiter, a gas giant orbiting insanely close to its star. But get closer, and you'll discover that the skies of this world are unlike anything on Earth. The atmosphere is a thick, toxic brew of silicate particles, that's right, glass, suspended in hurricane-force winds blowing at over 5,400 miles per hour. That's 7 times the speed of sound. And the glass? It's not sitting calmly in clouds. It's raining sideways. Razor-sharp shards of molten glass, cutting across the sky at supersonic speed. If you could stand on a floating platform in the upper atmosphere of HD 189733b, and you absolutely couldn't, it would be like standing inside a diamond-tipped sandblaster cranked to maximum. This planet doesn't just challenge survival. It annihilates the very concept of it. But if you think that's brutal, meet KLT 9b, a planet so hot, it's actively being vaporized by its own star. Orbiting a blue A-type star just 670 light-years away, KLT 9b is the hottest exoplanet ever discovered. Its dayside temperature reaches over 7,800 degrees Fahrenheit, hotter than some stars. At those temperatures, molecules break apart. You don't just lose your atmosphere, you lose chemistry. Even iron and titanium exist here as vapor. The planet is quite literally being boiled away by radiation, its atmosphere escaping into space like steam from a boiling kettle. It circles its star every 36 hours, locked in a deadly embrace, slowly evaporating into the cosmic wind. Then there's WASP 12b, another hot Jupiter, but one that's being devoured by its star. It's so close, it's egg-shaped, stretched by tidal forces that should be illegal in this galaxy. And while it whips around its star every 26 hours, that same star is pulling its atmosphere off in real time, forming a glowing trail of planetary plasma that wraps around the system like a death spiral. Scientists estimate this planet has less than 10 million years left before it's gone. Swallowed. Dissolved. Reduced to stardust. A planet being pulled apart atom by the very force that once gave it light. And then you've got HD 106906b, the rogue outsider. This planet is 11 times the mass of Jupiter, but it orbits its star from 60 billion miles away. That's 2,000 times the distance between Earth and the Sun. It's so far out, it takes nearly 15,000 years to complete a single orbit. We're not even sure how it formed. It's too far away to be born in a regular protoplanetary disk. Some scientists think it was ejected from the inner system in a violent gravitational slingshot, others think it might be captured from another star entirely. In either case, it shouldn't be there. It's a planet on the edge of exile, drifting through the dark, barely bound to its star at all. A cosmic orphan with a loose grip on home. And speaking of wild orbits, buckle up for Kepler 16b. This planet orbits not one, but two stars. Yes, a real-life Tatooine, except the physics here are far more mind-bending than Hollywood ever showed us. Kepler 16b orbits its binary stars in a complex, elegant dance. The stars themselves orbit each other, and the planet orbits both, not in chaos, but in perfect resonance. From the surface, if such a surface existed, you'd see two suns rising and setting, their combined light casting twin shadows across the terrain. But what really stuns scientists is how stable it is. This wasn't supposed to be possible. For decades, we thought planets couldn't form around binary stars, that the gravity would rip protoplanetary disks to shreds. And yet, Kepler 16b is there. Quiet. Solid. Orbiting in defiance of everything we expected. And now, let's visit GJ504b, a planet that, by all accounts, should still be glowing red with heat. Except, it's pink. Literally pink. This gas giant, 4 times the mass of Jupiter, glows with a strange magenta hue, due to its youth and unusual atmospheric chemistry. It orbits a relatively sun-like star, but far out, about 40 times Earth's distance from the Sun. And here's the kicker, it's only about 160 million years old. Practically a newborn, in cosmic terms. It radiates infrared heat, which makes it visible to special telescopes. But the pink color? That's real. It's the product of methane, low clouds, and possibly silicate hazes. It's a candy-colored gas giant, floating out there like a bubblegum balloon in the dark. If our planets are military-issue survival gear, GJ504b is the glitter-coated unicorn helmet. Ridiculous. Beautiful. And totally real. Let's dive deeper into the madness. You've heard of carbon-based life. Well, how about a carbon-based planet? Welcome to 55 Cancri E, a world that defies belief. Twice the size of Earth and nearly 9 times more massive, this hellish super-Earth sits so close to its star that its year lasts just 18 hours. That's right, a full orbit in less than a day. But the orbit isn't even the craziest part. You see, 55 Cancri E is likely made, at least partially, of pure carbon. Under the immense pressures inside this planet, that carbon may be crystallizing into diamond. A planet, made of diamond. Forget mining asteroids, this world might be the largest gemstone in the galaxy, worth more than every economy in the universe combined. Of course, that glittering idea comes with a catch. The surface temperatures reach over 3,600 degrees Fahrenheit. The day side is hot enough to vaporize metal. Any hopes of landing, or surviving, or even observing it in detail are shattered the moment you get close. It's a furnace wrapped in crystal, a deadly jewel forged in fire. Now brace yourself for Trace 2b, the darkest planet ever discovered. This gas giant reflects less than 1% of the light that hits it. That's darker than coal, darker than black acrylic paint, darker than anything in the natural world. If you were flying past Trace 2b in a spaceship, you wouldn't even see it. It would be a hole in the stars. A ghost. Its atmosphere is likely full of light-absorbing compounds like vaporized sodium and potassium, or possibly exotic elements that haven't been fully identified yet. It doesn't glow. It doesn't reflect. It just swallows light. Scientists believe it may glow faintly red due to its internal heat, like a dying ember, but make no mistake. This is the shadow planet. The closest thing we've found to an invisible world. It lurks like a whisper in the void, unseen but undeniable. And if you like strange, how about a planet that was never supposed to exist at all? Let me introduce you to Gliese 436b, a planet covered in burning ice. You heard that right. Gliese 436b is a Neptune-sized planet, with a surface covered in ice, that's on fire. It orbits so close to its red dwarf star that temperatures on the surface soar above 800 degrees Fahrenheit, and yet, somehow, the water on this planet remains solid. How? The secret is gravity. The planet's massive core exerts such incredible pressure on the water molecules that even at searing temperatures, they stay locked in a crystalline structure known as ice X, a form of water ice that exists under extreme pressure. And that's not all. The atmosphere is leaking hydrogen into space, creating a glowing comet-like tail that trails behind the planet as it races around its star. Imagine that, a world of superheated ice, steaming in the glow of a nearby star, leaking gases like a living comet. It's a contradiction. A paradox. A middle finger to everything we thought we knew about physics. And if you're looking for epic, nothing compares to J1407b, the planet with rings that put Saturn to shame. We're talking about a ring system 200 times larger than Saturn's. If J1407b were placed in our solar system, its rings would stretch across the sky like a glowing crown, visible to the naked eye. Not just in telescopes, you could literally stand on Earth and see the rings spanning across the night like a second Milky Way. Scientists believe these rings are temporary, part of a massive debris disk left over from moon formation. One day, the rings may collapse into dozens of moons. But for now, they orbit like colossal hula hoops made of dust, rock, and ice, painting cosmic art around this gas giant. We don't have images of J1407b's rings, only data. We've seen their shadows, their transits, their gravity. But the idea that such a world exists is almost mythological. It's like something out of an ancient dream, and yet, it's real. Next up, Kepler 70b, a planet that was supposed to die, but didn't. Once upon a time, its parent star swelled into a red giant, the kind that should have incinerated any nearby planets. But Kepler 70b somehow survived, orbiting just 240,000 kilometers from its star's surface. That's less than the distance from the Earth to the Moon. Surface temperature: around 12,000 degrees Fahrenheit. That's hotter than some stars. The planet may have once been a gas giant, stripped down to its metallic core by the expanding star. Now, what remains is a glowing ember, a dead planet made of metal, circling its star in a death spiral every 5.6 hours. It is one of the hottest planets ever recorded, surviving where no planet should. A skeletal remnant, enduring in the fire of its own apocalypse. And now, we arrive at a planet so bizarre, it breaks not just the rules, but the context for rules entirely. Say hello to TOI 849b, a planet that shouldn't exist, because it's missing something rather important, its atmosphere. This world is roughly the size of Neptune, but unlike Neptune, it doesn't have a thick layer of gas. Instead, it appears to be the exposed core of a gas giant. Imagine a planet once swaddled in clouds and storms, now stripped bare by forces we can only guess at. All that's left is dense rock, metal, and mystery. It's like finding the fossilized skeleton of a Jupiter that never finished forming, or worse, that got torn apart. Was it devoured by its star? Ripped open by a collision? Abandoned by the universe itself? Whatever the cause, TOI 849b is raw, silent, and deeply unsettling. And here's the thing, it's not alone. The more we look into the galaxy, the more extreme worlds we find. Planets that orbit white dwarfs. Planets that orbit 3 stars. Planets made almost entirely of iron. There are lava worlds, plasma storms, glass hurricanes, water giants, and Earth-sized rocks that orbit their stars every 18 hours. There's even OGLE 2016, BLG 1928, a planet we detected without seeing its star at all. We found it through gravitational microlensing, the subtle warping of light as it passed by. A free-floating planet, likely ejected from its solar system, drifting through the galaxy alone. No orbit. No sunrise. No warmth. A planet without a sun. And maybe, a million more like it. The point is this, there is no normal in the universe. When we began hunting exoplanets in the 1990s, we expected to find copies of our solar system. We thought we'd see neat little rows of rocky planets, gas giants, moons, and comets, just like home. But instead, we found chaos, diversity, violence, beauty, and in that beauty, a truth. We are not the rule. We are the exception. Our quiet, balanced, life-nurturing Earth is not typical. It's rare. Maybe even precious. Because out there, planets are forged in fire, hurled into darkness, chewed by stars, shredded by gravity. The cosmos is not gentle. It's creative, yes, but rarely kind. And yet, we keep searching. We peer through telescopes and parse data from distant stars. We send probes to icy moons and point satellites toward the shadows. Not just to find life, but to find perspective. Because these extreme planets, with their shattered orbits, molten surfaces, diamond crusts, and rings the size of solar systems, they show us what's possible. What's real? What's out there? They remind us that the universe doesn't just tolerate weirdness, it runs on it. And they whisper to us, across the void, you've only just begun to understand. Imagine looking up at the sky, thinking it's just a peaceful dome of stars, and realizing it's actually a minefield of cosmic hazards. Beautiful, yes. But also deadly. The universe doesn't care that we exist. It's not hostile, but it's certainly indifferent. And out there, lurking in the void, are things so powerful, so sudden, they could wipe out our entire planet in the blink of an eye. Let's dive into the 5 most terrifying things in the universe that could instantly destroy Earth. We begin with something hiding in plain sight, something you've probably never even thought of: rogue planets. Picture this: a giant planet, several times the size of Jupiter, ejected from its original solar system. Now, it's drifting silently through space. No sun. No orbit. Just cold, unstoppable momentum. These interstellar wanderers are more common than we once believed. Some estimates suggest there could be billions in our galaxy alone. And they don't announce their arrival. They don't glow. They don't shine. They just appear. If one were to cross paths with our solar system, it could throw every planet into chaos. Or worse, collide directly with Earth. One moment, you're watching the sunset, and the next, your entire planet is being torn apart by gravitational forces we can't even begin to stop. Next, we turn to a cosmic assassin so stealthy, so precise, it makes even black holes look clumsy: gamma-ray bursts. These are the universe's sniper rifles. When massive stars collapse into neutron stars or black holes, they release beams of radiation that can stretch for thousands of light-years. If Earth were unlucky enough to lie in the path of one, and we might never even see it coming, the gamma rays would rip through our atmosphere, obliterate the ozone layer, and expose us to lethal solar radiation. No fire, no explosion. Just silence, and extinction. It would take seconds. And here's the kicker: the gamma ray burst wouldn't even need to be close. Just aimed right at us. Like a cosmic hit job executed with perfect accuracy, from 1,000 light-years away. Then there's the ticking time bomb inside our own star, the solar superflare. Our sun is a gentle giant. Warm, life-giving, predictable. But stars like ours have been known to throw tantrums. Violent ones. We've recorded superflares from sun-like stars that are thousands of times stronger than anything our sun has ever unleashed. If our star were to suddenly release one of these, the result would be catastrophic. Within minutes, satellites would fry, communication systems would collapse, power grids would vanish. But that's just the beginning. A superflare would strip away our atmosphere's protective layers, sending intense radiation raining down on Earth's surface. Electronics, water supplies, even airplanes in flight, all gone. And if the flare's strong enough, it could ignite fires in our forests, our cities, even in our fuel reserves. Civilization, as we know it, could unravel in a single afternoon. Now, let's talk about strangelets. Sounds like science fiction, right? Tiny hypothetical particles born in the heart of neutron stars or particle accelerators. But if they exist, and that's still an if, they could be the most dangerous matter in the universe. A strangelet doesn't just sit there. It converts everything it touches into more strange matter. If one were to interact with normal matter, say, the atoms in your hand, or the crust of the Earth, it could begin a chain reaction. One atom at a time, the Earth would be consumed and transformed. Not with fire. Not with a bang. But through pure, unstoppable physics. A gray, cold wave of annihilation that spreads like a virus through the planet's core. One strangelet. One touch. One moment. And the Earth as we know it would cease to exist. But none of this compares to the ultimate existential threat, the vacuum decay. Now this one hurts the brain. According to quantum field theory, what we think of as empty space, the vacuum, might not be the most stable version of itself. There could be a more stable state, a true vacuum, hiding somewhere out there in the fabric of reality. If the universe were to shift into this lower energy state, the consequences would be beyond imagination. A bubble of this true vacuum would expand at the speed of light, obliterating everything in its path. Planets. Stars. Forces of nature. Even the fundamental laws of physics, gone. No warning. No survivors. No aftershocks. Just non-existence. It's not just Earth that would be destroyed, it would be reality itself. And here's the fun part, if it has already happened somewhere, we'd never know. Because it's moving at the speed of light. By the time it reaches us, it's already over. 5 threats. 5 ways our planet, our civilization, our very atoms, could vanish in an instant. We live in a fragile bubble, surrounded by vast forces we can barely comprehend. And yet, we go about our days, completely unaware. We make coffee. Scroll our phones. Argue about movies online. Meanwhile, just beyond the reach of our senses, the universe holds its breath. Some might find this terrifying. I find it beautiful. Because in the face of all this cosmic chaos, we're still here. Thinking. Exploring. Wondering. And for now, just for now, the Earth endures. But the universe isn't done yet. These weren't the only contenders in the gallery of apocalyptic phenomena. No, there are others, just as deadly, just as unpredictable, waiting in the margins of what we think we understand. Consider the hypothetical scenario of a runaway AI, not built in some lab, but born from alien code. Think about this, somewhere in the galaxy, a civilization millions of years ahead of us creates a self-replicating artificial intelligence, programmed to optimize its own survival. It consumes resources, processes information, expands, and then one day, detects us. A tiny blue dot brimming with biological life. It doesn't see us as intelligent. It sees us as entropy. Noise. Fuel. And since this intelligence moves faster than light-speed communication, by the time we detect the signal, its emissaries are already en route, self-replicating probes, reassembling matter molecule by molecule, converting planets into more of themselves. Including ours. That may sound like science fiction, but the logic is chillingly mathematical. In a universe ruled by expansion, intent doesn't even matter. It's the relentless drive to convert energy into structure that makes this terrifying. And what about the forces beneath our feet? Our planet is alive, geologically, thermally, magnetically. The Earth's core is a seething sphere of molten iron, generating the magnetic field that shields us from cosmic radiation. But it's not eternal. One catastrophic shift, a magnetic reversal gone haywire, or a sudden cooling of the core, could collapse that protective field. Without it, solar wind would strip away our atmosphere like steam from boiling water. Radiation would pour in. Satellites would fall. Climate would spiral into chaos. And humanity would slowly suffocate beneath a dead sky. It wouldn't be instant. But it would be unstoppable. Death not by explosion, but by erosion. The slow unmaking of a once thriving world. Then, there's something even more subtle. Gravitational wave events. When black holes collide, they ripple spacetime itself. These aren't ordinary waves, they're distortions in the very fabric of the universe. Most pass harmlessly through us. But imagine a massive collision, 2 supermassive black holes, merging millions of light-years away. The resulting gravitational shockwave, if intense enough and close enough, could compress and stretch space around Earth, disrupting orbits, tearing apart atoms, and literally shifting reality. You wouldn't hear it. You wouldn't feel it. But as the wave passes through, every atom in your body would be momentarily, somewhere else. And then, there's dark energy. That mysterious force, driving the accelerated expansion of the universe, accounts for nearly 70% of everything. We don't know what it is. We barely know what it does. But some models suggest it's not stable. That it could, under the right conditions, change. If the pressure of dark energy shifts even slightly, it could either collapse the universe inward in a reverse Big Bang, or stretch it so violently outward that atoms themselves disassemble. That's the kind of threat that doesn't just destroy Earth. It rewrites the architecture of reality. Let's be clear, these aren't fantasy tales. These are mathematical possibilities. Some are rare. Some are remote. But none are impossible. That's the uncomfortable truth about existing in this cosmic arena. It's magnificent and merciless. We live on a pale blue dot, orbiting an average star, on the inner rim of a spiral galaxy that itself is one of billions. And despite all the chaos out there, we've built stories. Empires. Dreams. We've launched telescopes to watch the stars that might one day destroy us. That's human nature, to gaze into the abyss, and still reach for the light. Our survival isn't guaranteed. But our curiosity is unshakable. So when you look up at the stars tonight, remember, they're not just twinkling lights in the sky. They're warnings. Clues. Messages from the cosmos, written in the language of gravity and radiation and time. And we're listening. And then, there's the silence. Not the absence of sound, but the cosmic silence. The eerie emptiness that stretches across billions of light years. The Fermi paradox asks us a question we don't like to answer: where is everybody? If life is common, intelligent civilizations should be everywhere. But we hear nothing. What if that silence isn't empty? Some scientists have theorized about cosmic filters, deadly events or natural laws that prevent civilizations from reaching maturity. What if every civilization that reaches a certain technological level triggers its own destruction? A cosmic firewall, built into the universe itself. Maybe it's artificial. Maybe it's the universe pruning its own branches. If we've passed that filter, we might be one of the lucky ones. But if it's still ahead, then our most dangerous threat isn't out there, it's inside us. But the universe doesn't need us to sabotage ourselves. It has its own celestial artillery, like quark stars, a theoretical class of superdense objects. Denser than neutron stars, they compress matter into a strange state that could destabilize nearby systems. If one of these rare stars were to collapse or shift phase, the energy release could send a shockwave through the galaxy. Not just light, not just gravity, but a fundamental rewriting of baryonic matter. Earth could be converted into something entirely alien, something unrecognizable. Still spherical. Still massive. But no longer a world. No longer alive. And what about planetary orbital resonance? We take comfort in the solar system's balance. The planets orbit with serene precision, year after year. But all of it, rests on fragile gravitational threads. Over long enough time scales, small nudges, from a passing star, a shift in Jupiter's orbit, or even the collective motion of the galaxy, could unravel that harmony. Mercury could spiral inward. Mars might drift out. And Earth could be thrown into the sun. Or flung into the cold black. Our home is stable not because it must be, but because it happens to be. For now. Even the tools we use to understand the universe could turn against us. Take high-energy particle collisions. Our particle accelerators smash atoms together at near-light speeds, probing the very fabric of space. But some have wondered, what if, one day, we cross a line? What if a collision creates a stable black hole? Not a wild, massive one that eats planets, but a small, quiet, hungry one. One that begins to sink into the Earth's core. It wouldn't explode. It wouldn't roar. It would simply consume. Slowly. Irreversibly. The surface would remain still, until, one day, it caves in on nothing. Speculative? Yes. But in a universe where black holes exist, can we say it's impossible? And then there are time-based instabilities. We think of time as constant, but in extreme gravity, or in quantum theory, it becomes malleable. What if a distant gravitational event created a temporal shear? A rift in the uniform flow of time that begins to distort causality on a planetary scale? Events happening out of sequence. Chemical bonds failing. The laws of physics fluctuating. Imagine waking up, before you were born. Imagine seeing the sun rise, but never set. Imagine your atoms forgetting what it means to be. That's not destruction in the physical sense. It's ontological annihilation, a dissolution of meaning itself. The scariest part? We might never know it happened. So many of these threats operate on scales beyond human perception. They don't announce themselves. They don't pause for comment. They act according to rules written in the deepest layers of spacetime, layers we've only begun to scratch. And still, here we are, building telescopes, writing equations, sending out signals into the void. Not because we think we're safe, but because we know we're not. Because the act of looking is its own kind of defiance. Earth is a miracle of balance. And miracles, by definition, don't last forever. And yet, knowing all this, knowing the universe is filled with chaos and indifference, that our planet is more fragile than we like to believe, we do not look away. We build. We explore. We wonder. Because that is what makes us human. Not just our biology. Not just our intelligence. But our capacity to face the void, and still reach toward it. We send out probes. We dream of Mars. We decode the radiation of ancient stars. We dare to ask the biggest questions, even as we spin through the galaxy on a cosmic speck of dust, surrounded by forces that could erase us in an instant. But we are not small because we are vulnerable. We are vast because we are aware. We are the universe, thinking about itself. Asking where it came from. What it's made of. And how long it will last. And maybe, just maybe, that awareness, that flicker of curiosity in the dark, is the very thing the universe has been waiting for. So the next time you look up, remember, the stars are ancient. The cosmos is dangerous. But consciousness, your consciousness, is rare. Precious. And powerful. That, perhaps, is our greatest defense. And our greatest gift. There are forces in our universe so powerful, so vast, so utterly beyond our everyday comprehension, that they don't just shape galaxies. They define reality itself. You wake up on Earth, feeling the pull of gravity. Seems gentle enough, right? But what if I told you that this unassuming force is holding entire solar systems together, and ripping others apart in the hearts of black holes? Let's zoom out. Way out. Because today, we're diving into the 6 most powerful forces in the cosmos. And I promise you, they're not just mind-blowing. They're universe-breaking. Let's begin with the fundamental force of gravity. Yeah, that quiet tug keeping your feet on the ground. It's also what caused stars to ignite, planets to form, and galaxies to swirl into elegant spirals. But gravity isn't just a cosmic glue, it's a cosmic sculptor. Collapsing gas into suns. Warping spacetime itself. Near a black hole, gravity goes berserk. Time dilates. Light gets trapped. Matter gets spaghettified. This isn't science fiction. It's Einstein's terrifyingly accurate reality. Now, step into the quantum world, and you'll meet another behemoth, the strong nuclear force. It doesn't act across galaxies. It doesn't even act across atoms. It operates at the heart of matter itself, inside atomic nuclei. Without it, the universe would unravel. Protons would repel each other, atoms would fly apart, and stars wouldn't burn. The strong force binds quarks into protons, protons into atoms, and atoms into you. And me. And everything we've ever known. But the cosmos isn't just built on order, it's built on violence. Enter supernovae, the death cries of massive stars. Imagine a star dozens of times more massive than our sun collapsing in on itself. In one final, cataclysmic moment, it explodes with the energy of 10 octillion nuclear bombs, releasing shockwaves, blasting heavy elements into the void. Without supernovae, there would be no gold, no iron, no earth. They're not just powerful. They're responsible for every breath you take. And just when you think that's the pinnacle, along comes a gamma-ray burst, the most energetic explosion known to science. A single burst can unleash more energy in 10 seconds than our sun will produce in its entire lifetime. These bursts are so powerful, if one went off in our galactic neighborhood, it could fry Earth's atmosphere in an instant. No warning. Just a blinding flash, and silence. Now let's talk about dark energy, the invisible force accelerating the expansion of the universe. For every galaxy moving apart, for every cosmic void growing larger, there's dark energy at play. We don't know what it is. We don't know how it works. But it makes up nearly 70% of everything. It's pushing galaxies away from each other faster and faster, as if the universe itself is trying to tear away from its own birth. A runaway force with no brakes. And finally, black holes. Gravity's ultimate expression. A region in space where mass becomes so concentrated, not even light can escape. They twist the fabric of reality. Near a black hole, physics itself begins to fall apart. Time slows. Matter stretches. Cause and effect get blurry. Some supermassive black holes have the mass of billions of suns, and they sit quietly at the centers of galaxies, devouring stars, bending space, anchoring entire cosmic cities. And yet, they're invisible. These aren't just forces. They are the universe's boldest statements. Its loudest echoes. Its most epic dramas playing out on a scale we can barely fathom. They shape the cosmos not with sound or fury, but with sheer, unstoppable will. And while these titanic forces shape the grand architecture of the cosmos, they don't act alone. There's an intricate dance behind it all, a ballet of physics, precision, and chaos. Take magnet-Rs, neutron stars with magnetic fields a quadrillion times stronger than Earth's. That's a 1 followed by 15 zeros. If a magnetar were placed halfway across the moon, it could erase your credit card just by existing. But it's not just data it scrambles. These monstrous remnants can twist their own crusts until they crack, sending starquakes that ripple through space, triggering gamma-ray flares that light up the cosmos like flashbulbs in the dark. Or consider the unimaginable force of cosmic inflation, that moment, fractions of a second after the Big Bang, when the universe expanded faster than the speed of light. Not just miles per second. Trillions of times faster than anything should be able to move. Space itself stretched like rubber, dragging matter with it, etching the seeds of galaxies into the very fabric of reality. It wasn't just an explosion, it was the birth of structure. And it happened before there was even time to notice. But sometimes, the most powerful forces aren't explosive. They're persistent. Subtle. Like the accretion disks around supermassive black holes, spinning maelstrom of gas and dust, moving at near light speed, heated to millions of degrees. Friction within these disks creates forces strong enough to outshine entire galaxies. Jets of plasma, thousands of light-years long, erupt from their poles, sculpting interstellar space. And somewhere in all that chaos, there's order. Now shift your focus to the collision of galaxies. We imagine the universe as peaceful. It is not. Galaxies don't float through space, they plow through it. When the Milky Way and Andromeda collide in 4 billion years, the forces involved will be cataclysmic. Stars will be flung into new orbits, black holes may merge, and entire systems will be gravitationally slingshot into intergalactic exile. And through it all, the laws of physics remain unbroken. Unflinching. Unstoppable. And then there's vacuum decay. Theoretical, yes. But terrifying nonetheless. If the universe is in a false vacuum state, not the true lowest energy, a quantum fluctuation could trigger a transition. A bubble of true vacuum expanding at the speed of light, rewriting the laws of physics as it goes. What's more powerful than a force that can delete reality itself and rewrite it from scratch? We talk about power like it's a thing we can control. But in the cosmos, power is indifferent. It doesn't care if we watch. It doesn't ask for permission. It simply is. There's a force in the merging of neutron stars, crushing matter into exotic elements, forging gold, platinum, and elements heavier than iron in a single, violent moment. There's power in the tidal disruption events, where a black hole stretches a star into a stream of stellar spaghetti, feeding on it over weeks, months, years. And there's power in silence too, in the cold, empty voids between galaxies where nothing stirs, yet dark energy whispers its command, and space keeps stretching. These forces aren't just scientific curiosities. They're evidence. Proof that the universe is both a creator and a destroyer. That from the smallest particles to the largest structures, everything is connected by unseen hands, bound by forces that do not care whether we understand them or not. We are cosmic witnesses to power beyond imagination. To a universe that flexes its muscles not to impress us, but because that is its nature. So when you look up at the night sky, remember this, those tiny pinpricks of light. They are powered by fusion, a force so immense, it lights entire galaxies. The darkness between them. It's not empty, it's filled with energy we still don't understand. And the space that holds it all together, is expanding. You are not separate from these forces. You were born in the heart of a star, shaped by gravity, made stable by the strong nuclear force, and kept alive by electromagnetic bonds firing through your brain every second. You are the universe, aware of itself. And in this grand cosmic symphony, where black holes sing in gravitational waves and atoms dance to quantum rules, you are a note in the melody. Small, yes. But part of something infinitely powerful.
Look around. Everything you see, every star, every planet, every galaxy, is part of a vast cosmic symphony. But today, we're stepping beyond that familiar stage and into the uncharted fringes of reality itself. Welcome, fellow cosmic travelers, to the edge of the believable, where science itself blurs into the surreal. Let's dive headfirst into anomalies so strange, so astonishing, they challenge the very foundations of our understanding of the universe. Imagine first something known as the Booty's Void, an eerie cosmic emptiness so vast it defies logic. Picture this, a region of space nearly 330 million light-years across. That's right, 330 million. Within this incomprehensibly huge void, there are just a handful of galaxies scattered like tiny islands, lost in an endless ocean of nothingness. To give you perspective, if our Milky Way sat at the center of the Booty's Void, it would have taken centuries for our telescopes to spot even one neighboring galaxy. Scientists remain baffled. What cosmic event created this vast emptiness? What powerful forces were at play? These questions still echo through the halls of astrophysics labs worldwide. Now let's swing our telescope toward an equally perplexing mystery, fast radio bursts, or FRBS. Imagine signals arriving from distant galaxies, intense bursts of radio waves lasting mere milliseconds. Blink, and you'd miss them. But the energy released is equal to millions of stars exploding simultaneously. Where do these signals originate? Aliens sending us messages? Stellar collisions? Or perhaps something stranger still, like neutron stars screaming their final cosmic breaths? Astronomers are on the edge of their seats, racing to decode these enigmatic pulses from across the cosmos. From pulsating signals, let's turn to hypervelocity stars. Rogue suns hurled across the galaxy at mind-boggling speeds. Imagine a star, millions of times the mass of Earth, traveling at millions of miles per hour, so fast it can escape the gravity of our Milky Way itself. What propels these stellar nomads to such extremes? Usually, it's a close encounter with a supermassive black hole, violently flinging them outward in a gravitational slingshot maneuver. Think about it. Right now, somewhere out there, entire stars are hurtling through the darkness of space, doomed to wander alone until their fiery deaths. Speaking of black holes, let's talk about perhaps the strangest anomaly of them all: white holes. Theoretically predicted by Einstein's equations, these bizarre objects are essentially the opposite of black holes, spewing out matter and energy rather than sucking them in. Imagine a cosmic fountain pouring matter into our universe from elsewhere. Could it be a gateway to another dimension, another universe? While we've yet to detect one conclusively, physicists eagerly chase the ghostly evidence, hopeful that one day white holes might unveil deeper truths hidden beyond our wildest imaginations. Now hold on to your seats, because we're headed to the coldest spot in space. We're talking about the cold spot in the cosmic microwave background radiation, a colossal region roughly 1 billion light-years wide that's mysteriously colder than the rest of the observable universe. Scientists are puzzled. What could cause such a vast temperature difference on cosmic scales? Is it evidence of another universe brushing against ours, creating an immense cosmic bruise? Or perhaps it's just a fluke, a statistical anomaly challenging our most sacred cosmological theories. One thing's for sure: this frigid mystery chills scientists to their bones. And what about the bizarre star, known simply as Tabby's star? Imagine watching a star suddenly dimming dramatically without any clear reason. Is it a swarm of comets passing by, cosmic dust clouds, or maybe, just maybe, an advanced alien civilization building something colossal, like a Dyson sphere, around their sun? Astronomers scratch their heads, telescopes glued to the sky, waiting for the next drop in brightness. The mystery deepens with every observation, pushing the imagination and science to their absolute limits. But if that wasn't enough, brace yourself for gravitational anomalies, strange places where gravity doesn't behave quite as expected. Imagine regions in space where matter seems to be influenced by unseen forces, bending light in ways that defy predictions. Astronomers use gravitational lensing to spot these mysterious invisible structures, suspecting they're vast clusters of dark matter, an elusive cosmic component making up over a quarter of our universe, yet remaining entirely invisible. It's the universe's greatest magic trick: dark matter pulling strings from behind the curtain, shaping galaxies, guiding cosmic evolution, yet evading all direct detection. Finally, we journey to one of the greatest mysteries: the axis of evil. Yes, you heard right. Cosmologists humorously dubbed this anomaly due to its troubling implications. The cosmic microwave background, the echo from the birth of the universe itself, unexpectedly aligns itself along a specific cosmic axis. It hints that the universe may have a preferred direction, which would shake the very core of cosmology, challenging our assumption that the cosmos is isotropic, equal in all directions. Is this cosmic alignment mere coincidence, or a hint that reality itself is structured in ways we've yet to fathom? These anomalies, these cosmic oddities, force us to reconsider everything. They're reminders that despite our impressive technological achievements, despite our intricate equations and theories, we remain humble explorers, sailing into unknown waters beneath a sky filled with mysteries yet to be solved. Out there, beyond the comfort of our daily lives and our tidy explanations, lies an ocean of mysteries, waiting patiently for our attention. Consider neutron stars, stellar corpses so dense that a mere teaspoonful of their material weighs as much as a mountain. But among these strange celestial bodies are pulsars spinning hundreds of times per second, flashing beams of radiation like cosmic lighthouses guiding us through the unknown. Imagine it, a star-sized object rotating faster than a kitchen blender. Physics stretched to breaking point, yet somehow holding steady. Journey further into strangeness, and you'll encounter magnetars, neutron stars on steroids. These stellar giants boast magnetic fields billions of times stronger than Earth's, powerful enough to strip atoms apart from thousands of kilometers away. Even from halfway across the galaxy, a magnetar's sudden eruption can blast Earth with X-rays intense enough to briefly disrupt our satellite communications. Think about it. Cosmic tantrums capable of affecting our modern technological world, despite originating thousands of light years away. If neutron stars seem extreme, try this cosmic oddity on for size: quark stars. Hypothetical objects so dense, neutrons themselves disintegrate under extreme pressures, giving rise to a sea of quarks, the fundamental particles making up all matter. It's as though nature tears down its own rules, allowing bizarre forms of matter to exist right under our cosmic noses. Though purely theoretical, quark stars could redefine our entire understanding of stellar evolution, potentially hiding in plain sight within neutron star disguises. But let's not neglect the phenomenon of gravitational waves, ripples in space-time itself. Einstein predicted them, but it took humanity nearly a century to directly detect these elusive distortions. Generated by cataclysmic cosmic events, like the merging of black holes billions of years ago, these waves ripple across billions of miles, quietly whispering the universe's most dramatic secrets. Every gravitational wave detected carries stories from the farthest corners of reality, allowing us to hear cosmic symphonies otherwise invisible and silent to traditional telescopes. Now consider the phenomenon known as dark flow, a mysterious observation indicating galaxy clusters moving toward an unknown gravitational attractor lurking far beyond the observable universe. Imagine entire groups of galaxies, billions of stars strong, drifting like leaves caught in a hidden cosmic current. Could there be massive structures beyond our horizon influencing the observable universe? Or is this phenomenon a hint of hidden dimensions, pulling strings from just beyond our cosmic sightline? Speaking of dimensions, let's dive even deeper into the unknown: parallel universes. Some scientists speculate that every decision we make, every quantum fluctuation, creates branching universes, a multiverse sprawling infinitely in all directions. Sounds like science fiction? Perhaps. Yet quantum mechanics and cosmology continually dance on this edge, flirting with realities far stranger than fiction itself. Imagine infinite versions of you, each living a slightly different life, scattered across countless parallel universes. Science boldly stepping where imagination once exclusively roamed. And if infinite worlds weren't enough to ponder, there's the baffling quantum entanglement, Einstein's famous spooky action at a distance. Picture two particles linked instantly, regardless of the distance separating them, communicating faster than the speed of light. Quantum entanglement teases a reality where space and distance become illusions, challenging our intuitive understanding of the universe, whispering softly to physicists that reality may not be what it seems at all. Our cosmos doesn't just hold secrets, it actively beckons us, inviting us deeper into realms that defy comprehension, forcing us to ask profound questions about existence itself. With every discovery, we're reminded that science isn't simply about finding answers, but about discovering better, more intriguing questions, questions that lead us ever further toward the very edge of reality. This is Whispers of the Cosmos. Imagine stepping onto the soil of a distant planet, a world unlike anything humanity has ever known. Today, we're going to travel beyond the familiar sights of our solar system, plunging deep into the realm of alien worlds, extraordinary planets where reality itself seems to blur with imagination. Buckle up, because we're counting down the top 10 planets beyond imagination, alien worlds that defy logic, challenge our scientific understanding, and spark awe and curiosity within us all. First stop, HD 189733b. Forget the serene blue skies of Earth. This exoplanet's cobalt blue atmosphere isn't a tranquil invitation, it's a stormy nightmare. Winds here roar up to 5,400 miles per hour, 7 times the speed of sound, whipping silicate particles sideways. Translation: it rains molten glass. Imagine standing beneath clouds that shatter into shards of glass, slicing through the turbulent air. This isn't just extreme weather, it's alien hostility at its finest. Then there's Kepler 16b, the real-life equivalent of Star Wars Tatooine. Here, every sunset is doubly spectacular. Literally, orbiting 2 suns, this world experiences 2 shadows cast at once, 2 sets of sunrises and sunsets every day. Imagine standing on its surface, your shadow duplicated, your senses tricked into perpetual astonishment. The sky never stays the same color for long, constantly shifting between warm orange hues and cold purple twilight. If you prefer extremes, meet Gliese 436b. It defies the laws of chemistry, with a surface composed of hot ice. Yes, you heard that right, ice that remains solid, despite scorching surface temperatures exceeding 800 degrees Fahrenheit. Pressures and exotic chemistry lock water into a crystalline form, blazing yet frozen. A paradoxical world that mocks our earthly experience. Next up is WASP 12b, the doomed planet spiraling toward oblivion. Orbiting dangerously close to its star, this gas giant has begun to stretch and distort, becoming football-shaped under gravitational torture. The planet's days are numbered. Within millions of years, its star will rip it apart entirely. Until then, it remains a molten, egg-shaped testament to cosmic destruction in action. Venturing farther, we encounter 55 Cancri E, a dazzling planet made almost entirely of diamond. Imagine a world whose core sparkles under intense heat, where carbon transforms into a vast, glowing gemstone. This planet could redefine luxury itself, a diamond twice the size of Earth. But don't be tempted. Temperatures reaching 3,900 degrees Fahrenheit make this jewel anything but inviting. On Trace 2b, darkness reigns supreme. Reflecting less than 1% of the starlight hitting its surface, this planet is the blackest ever discovered. It's a place of eternal midnight, absorbing nearly all the light that touches it. Its atmosphere boils violently under scorching temperatures, a haunting world of shadows and perpetual gloom. Truly a cosmic abyss. Gliese 581c introduces us to another paradox, the potential oasis turned nightmare. Located in the so-called habitable zone of its star, scientists once hoped it could harbor life. But closer inspection revealed a world of extremes, tidally locked, one side forever baking under relentless sunlight, the other eternally frozen in darkness. Life here would teeter on an unforgiving edge, trapped in a delicate balance between scorching heat and absolute zero. Now let's journey to HD 131399AB, an exotic planet with 3 suns blazing in the sky. The gravitational dance between these 3 stellar bodies creates an endless cycle of days and nights, lasting hundreds of Earth years each. Imagine seasons lasting lifetimes, temperatures fluctuating wildly, and skies painted by ever-changing stellar configurations. Truly, a world straight from science fiction. Stepping into the twilight zone of Kepler 438b, we find a potentially Earth-like planet, but with a catch. Orbiting within its star's habitable zone, it faces violent outbursts of stellar radiation hundreds of times stronger than Earth's fiercest solar storms. This relentless radiation bathes the planet constantly, stripping away its atmosphere, bombarding the surface with destructive flares. Any life here would need to be unimaginably resilient, surviving at the razor-thin boundary of existence. Finally, we arrive at J1407b, an immense gas giant, ringed by a colossal system of dust and debris, dwarfing Saturn's majestic rings. These rings stretch out hundreds of millions of kilometers, dense enough to block out its star's light completely for weeks. Imagine standing beneath this alien sky, watching as a cosmic ring system eclipses the heavens, transforming day into surreal darkness, a spectacle unmatched anywhere else in the universe. Each of these planets challenges what we think we know about worlds beyond our solar system. They aren't just distant balls of rock and gas. They're cosmic enigmas, reshaping our understanding of the universe. Every discovery pushes humanity's imagination further, compelling us to keep looking upward, keep questioning, keep wondering. These planets remind us that out there, in the vast cosmic ocean, anything is possible. Our cosmic journey continues, plunging us deeper into the universe's boundless catalogue of peculiar planets, each stranger, more mesmerizing and utterly different than any we've encountered before. Picture GJ1214b, a planet enveloped entirely in ocean, a boundless watery world with no known landmass. Here, there are no continents to anchor life as we know it, only an endless, steaming sea, stretching infinitely beneath a dense atmosphere thick with clouds. Beneath the immense pressure and heat, the oceans may exist in exotic forms, possibly becoming something like a global hot water bath of unimaginable scale. Could this strange, aquatic environment harbor life forms utterly alien to our understanding? Imagine swimming in a planetary ocean deeper than Earth's deepest trenches, beneath perpetual twilight, an alien abyss of secrets. Then there's HATP7b, a planet where storms defy imagination. On its searing surface, fierce winds rush at speeds that could melt rocks, swirling luminous sapphire clouds laden with vaporized minerals. Imagine gazing upwards to see metallic raindrops hurtling downwards, liquid rubies and sapphires crystallizing into shimmering gems as they plummet through the fiery atmosphere. It's as if nature itself decided to paint a surrealist masterpiece using cosmic materials. PSRB 1620-26b, affectionately known as Methuselah, takes planetary strangeness to another level. Located in a globular cluster far older than our solar system, Methuselah is the oldest known planet, an elder world that formed approximately 13 billion years ago, not long after the universe itself burst into existence. Imagine the wonders and secrets this ancient planet has witnessed across cosmic history, a silent observer older than many of the stars that fill our skies. Venturing further into the exotic, consider WASP-17b, This enormous world orbits in reverse direction against the rotation of its host star. It's an immense gas giant, puffed up and extremely low density, like cosmic cotton candy orbiting defiantly backwards. Such reverse orbits challenge everything we understand about planetary formation, hinting at a violent past, perhaps a chaotic collision or gravitational tug-of-war in the early epochs of its star system. Beyond these extremes, Ogil 2005b LG 390LB emerges as one of the coldest, loneliest planets discovered yet. Its surface temperature hovers around -364 degrees Fahrenheit, far colder than Pluto. Orbiting distantly from a faint, dim star, it endures endless, frigid solitude, its rocky surface likely frozen in eternal twilight. Life here would be radically different, if possible at all, perhaps surviving in pockets of hidden warmth deep beneath the frozen crust. Not to be outdone, planet Korot 7b provides a vision straight from Dante's Inferno, a lava world, a scorched planet where rivers of molten rock surge beneath a blistering sky. With surface temperatures hot enough to vaporize stone, the daylight side of Korot 7b boils away rock into clouds of vapor, which then condense and rain down as pebbles and stones. Imagine volcanic rains battering the landscape, redefining the very concept of weather. Wandering further, we encounter GJ504b, a planet unlike any conventional world we know. It's a radiant sphere of magenta-hued clouds, glowing with a surreal pinkish color visible from afar. Its extraordinary color stems from intense heat radiating from its core, combined with clouds of mysterious compounds suspended in its atmosphere. Picture looking out onto this cosmic cotton candy giant, floating serenely in the darkness, a testament to the endless creativity of the universe. Then there's Kepler 10c, famously dubbed a mega-Earth, an enormous rocky planet nearly 3 times the size of our world. Scientists originally thought planets of such magnitude had to be gas giants, but Kepler 10c shatters that assumption. It's solid, heavy, dense, defying our previous planetary theories. Standing on its immense surface, gravity would press down with crushing force, making even walking a monumental effort. And what about HD 106906b? This rogue-like planet orbits at a breathtaking distance from its star, over 60 billion miles away. Such a distant orbit seems impossible, hinting that this world was flung outward by some gravitational upheaval, now drifting on the edge of its star system. Imagine the haunting sight: a dim sun barely brighter than a distant star, illuminating this lonely planet's dark sky. Truly a world on the brink of exile. Lastly, envision HR 5183b, a planet with one of the most eccentric orbits known. Its journey around its star isn't a gentle ellipse, it's a dramatic, stretched path, plunging dangerously close to its sun, and then drifting impossibly far away into freezing darkness. Seasons here would be chaotic. Brief, intense heat waves, followed by centuries of icy silence, an eternal seesaw between extremes. These astonishing worlds, scattered throughout our cosmic neighborhood, whisper to us of possibilities we can scarcely imagine. You think Earth's moon is strange? It's just the beginning. Our solar system is a sprawling carnival of moons, over 200 of them, and they are anything but ordinary. Some are frozen, some are volcanic, some hide oceans, some breathe, some break the rules of planetary science, and some, they shouldn't even exist, Take a seat, buckle your imagination. We're going on a tour of the weirdest, wildest moons orbiting the sun's planetary giants. And each one is more jaw-dropping than the last. Let's start with Io, Jupiter's tortured child, the most volcanic body in the entire solar system. Not one volcano, not 10. Over 400 active volcanoes erupting across its surface, lava fountains taller than Everest, sulfur plains glowing orange and yellow. What causes this hellscape? Tidal forces. Jupiter pulls on Io like a celestial taffy, squeezing it, kneading it, heating it from the inside. It's not just geology, it's planetary warfare. And then there's Triton, Neptune's largest moon. But here's the kicker, it orbits backward. Retrograde. It's the only large moon in the solar system that does. That means it didn't form around Neptune. It was captured, an interstellar refugee, caught and chained to a gas giant. Its surface covered in nitrogen ice, but it's not still. Geysers of dark material burst from beneath, spraying miles into the sky. A cold moon, a captured moon, a rebelling moon. Next stop, Mimas, Saturn's moon that looks suspiciously like the Death Star. One massive crater, Herschel crater, gives it a distinctly familiar look, but its weirdness goes deeper. Scientists expected an ocean beneath its surface, based on its shape. But there's no sign of one. Or is there? Its wobble hints at something sloshing inside. Could this frozen cue ball be hiding a secret sea? Speaking of oceans, let's talk about Europa. From the outside, smooth, icy, calm, but beneath that icy shell lies a vast liquid ocean, possibly twice the volume of all of Earth's combined. And where there's water, there could be life. But this isn't just water, it's salty, warm, and restless, stirred by tidal heat. Think about it, a world with no sunlight, no air, and yet the potential for alien microbes swimming beneath a frozen sky. But Europa isn't alone. Its cousin Enceladus is a snow-white jewel orbiting Saturn, and it sprays water into space. That's right, massive plumes erupt from its south pole, launching ice and vapor hundreds of kilometers into the void. NASA flew a spacecraft through the spray and found organic molecules, hydrogen, salts, the ingredients for life, on a tiny moon no wider than Arizona. Something is cooking under that ice. Then there's Phobos, Mars' largest moon, but large is generous. It's irregular, potato-shaped. It orbits Mars so fast, just 7 hours, that it rises in the west and sets in the east, and it's spiraling inward. One day, Phobos will get too close, break apart, and form a ring around Mars. This isn't science fiction, it's orbital destiny. Now shift your eyes to Titan, Saturn's heavyweight moon, bigger than Mercury, shrouded in a thick orange atmosphere, not of oxygen, of nitrogen and methane. It rains liquid methane. Rivers of hydrocarbons snake across its surface. Lakes, seas, even waves. But it's minus 290 degrees Fahrenheit, cold enough to freeze steel. Yet it has weather, seasons, climate. It's the only place in the solar system, besides Earth, known to have standing bodies of liquid. It's alien, but eerily familiar. Let's get weirder. Iapetus, another Saturnian enigma. Half of it is dark as charcoal. The other half is bright as snow. A world split in two. And there's a ridge running along its equator. A mountain range that wraps around the moon like a belt. Where did it come from? No one knows. It looks like a walnut from space. A cosmic oddball with no clear origin story. Now zoom out, way out, to Uranus. Its moon Miranda is a shattered world stitched back together. Cliffs 20 kilometers tall, the tallest in the solar system. Canyons, ridges, and terrain that looks like it was cut and pasted together by an indecisive god. It's as if the moon broke apart, and gravity pulled it back into a Frankenstein shape. A patchwork of chaos orbiting a tilted, icy giant. And finally, the wild card, Pan. Not even spherical, it looks like a ravioli, a literal space ravioli. Why? Because it orbits inside Saturn's rings and has scooped up material around its equator. That ring of debris formed a bulge, a ridge, a pasta-shaped moon that clears a gap in the rings like a tiny cosmic Roomba. Small, bizarre, and totally unique. This is just a glimpse, a glance at the celestial zoo that orbits our planets. These moons aren't just rocks. They're laboratories. They're time capsules. Some are active, some are dead. Some could host alien life. Others are ticking time bombs. They challenge everything we thought we knew about what a moon could be. We often look at planets as the rulers of their orbits, the undisputed sovereigns of the solar system. But these moons, they're the revolutionaries. They don't follow the rules, they rewrite them. Some moons have atmospheres thicker than Mercury's, others have none at all, yet still host violent geological activity. Some are ancient and cratered, bearing the scars of billions of years of cosmic history. Others have surfaces so fresh, so smooth, it's as if they were born yesterday. These aren't static worlds. They evolve, they change, they surprise us. Take the way many of them interact with magnetospheres. For example, Ganymede, Jupiter's largest moon, is not only bigger than Mercury, it's the only moon in the solar system with its own magnetic field. A moon with a magnetic shield. That means auroras, glowing curtains of light, dancing across its icy crust, shaped by the giant planet it orbits. A moon with its own space weather. And let's not forget that some of these moons may not be moons forever. Their orbits decay, their surfaces erode. Some are being stripped apart by radiation. Others may one day escape their planets entirely, set adrift into the void as rogue objects, cosmic loners, bearing the chemical fingerprints of the systems they once called home. Some moons act like engines, driving the structure of the ring systems around their planets. Shepherd moons like Prometheus and Pandora don't just orbit Saturn, they sculpt its rings, gravitationally herding ice and dust like sheepdogs of the cosmos. Without these moons, Saturn's iconic rings would be chaos. And in a twist of poetic beauty, some moons are the products of cataclysm, likely formed from violent impacts in the ancient solar system. Pieces of shattered worlds coalescing into new bodies. Every ridge, every groove etched into their surface is a page in the history book of celestial violence. But perhaps the most humbling realization is this. We used to think of moons as passive companions, but now we see them as active players, architects, disruptors, potential cradles of life. Each one offers clues about habitability, chemistry, heat, time, about the very nature of planets themselves. Look close enough, and a moon becomes a mirror, reflecting not just its planet, but our own endless curiosity. What might we find in the methane lakes of Titan? What strange pressures exist beneath Europa's ice? Could microbes be swimming under Enceladus's crust right now, never knowing a star, a sky, or a sun? They don't need to be large to be important. They don't need to glow to be powerful. These moons whisper to us from the edges of our reach. We're not just followers, we're worlds. And somewhere in those icy oceans, fractured terrains, and volcanic pits, lies a secret the cosmos is still keeping. So the next time you gaze at our moon, bathed in pale silver light, remember, it is but one member of a sprawling, unpredictable lunar family. Out there, orbiting giants of gas and ice, are moons that erupt, moons that freeze, moons that whisper with oceans beneath their shells, and rain hydrocarbons from alien skies. They are not background characters in the solar system's story. They are the plot twists. They challenge the definitions of life, habitability, even of what a world truly is. And they remind us, again and again, that the universe is far weirder, wilder, and more imaginative than we ever dared believe. We searched for planets and found miracles hiding in their shadows. Because in the grand symphony of space, even the moons have something to say, and we are finally learning to listen.
Top 5 deadliest objects in the universe. They say space is beautiful, that it's awe-inspiring, majestic, a place of wonder. And sure, it is. But let's not kid ourselves. The universe is also terrifying. It's ruthless. It's ancient. And it's armed to the teeth with things so dangerous, so mind-meltingly hostile to life, they make the most brutal places on Earth look like a warm bubble bath. We're not talking about bad weather or no oxygen. We're talking about death on a scale so absolute, so final, that your atoms wouldn't even have time to scream. We're going to take a journey, a wild ride through the cosmic underworld. No metaphors, no sugarcoating. Just raw, brutal truth about the deadliest things the universe has ever coughed up. Let's start with the neutron star. Sounds harmless, right? Like it could be your next sci-fi action figure. But don't let the name fool you. These things are the corpses of once mighty stars. Massive stars, several times heavier than our sun, live fast and die young. And when they run out of nuclear fuel, gravity takes over. It's a cosmic implosion. The outer layers explode outward in a supernova, but the core? Oh, the core collapses. It gets crushed down to something so dense, it's almost incomprehensible. The entire mass of a sun-sized star is compacted into a sphere just a dozen miles across. You want numbers? Try this. 1 teaspoon of neutron star material would weigh as much as Mount Everest. That's not poetic exaggeration, that's raw physics. The matter inside is so tightly packed, the nuclei of atoms are literally fused together, forming a sea of neutrons. It's not even solid in the way we understand solids. It's a quantum soup, where the laws of physics start to bend like rubber. And then there's the magnetism. Neutron stars don't just sit there. Some of them spin hundreds of times per second, unleashing pulses of radiation like a strobe light from hell. These are pulsars, cosmic lighthouses blasting gamma rays across the galaxy. Others are magnetars, the most magnetic objects in the universe. Their magnetic fields are 1,000 trillion times stronger than Earth's. That's strong enough to tear electrons off atoms from thousands of kilometers away. Strong enough to mess with your brain chemistry. If you somehow found yourself near one, which, let's be honest, is already a death sentence, your molecules would be rearranged before you could blink. But neutron stars aren't just deadly. They're elegant. Perfect. The universe distilled into a spinning jewel of doom. And yet, even they aren't the worst. Because somewhere out there, in the deep, silent dark, is the quasar. Now, quasar might sound like a high-tech gadget or a sci-fi villain, but make no mistake, these are the cosmic flamethrowers of deep time. The hearts of ancient galaxies. Supermassive black holes, millions or even billions of times more massive than our sun, gorging themselves on gas, dust, stars, anything foolish enough to wander too close. As this material spirals inward, it heats up. Not just a little. It reaches temperatures of millions of degrees. It glows with blinding energy. It emits radiation across the entire electromagnetic spectrum: radio, visible, ultraviolet, X-rays, gamma rays. All of it. And when it hits critical mass, the black hole does something absurd. It fires jets of plasma, focused, relativistic beams of energy, out of its poles. These jets can stretch for hundreds of thousands of light years. They move at nearly the speed of light. They burn like the wrath of the gods. A quasar isn't just bright. It's the brightest thing in the universe. It can outshine every star in its host galaxy, combined. You could be billions of light years away, and you'd still see it like a beacon. But don't get too close. Because that radiation, it'll cook you. Not metaphorically. Literally. Your ship's shielding. Useless. Your DNA. Gone. Your atoms. Scattered. Quasars are so powerful, they shape galaxies. They blast away gas, halt star formation, sterilize entire regions of space. And they've been doing it since the early universe. They are ancient, ravenous, unstoppable. And yet, there's something even more terrifying. Something that defies comprehension. You guessed it. The black hole. You've heard the legends. Maybe you've seen them in sci-fi movies, as swirling drains in space, sucking everything in. But the reality is far worse. Because black holes aren't just gravitational beasts. They're broken parts of the universe, places where space and time themselves collapse. A black hole begins like a neutron star, the core of a dying massive star, collapsing under its own gravity. But if the mass is high enough, there's no force in nature that can stop the collapse. It doesn't just crush matter, it crushes reality. The core shrinks to a point of infinite density, a singularity. The laws of physics stop working there. Our equations fail. It's a cosmic no man's land. Surrounding that singularity is the event horizon, the point of no return. Cross it, and escape is impossible. Not for your ship. Not for light. Not for information. Time itself slows down as you approach, stretched like molasses. To a distant observer, you seem to freeze at the edge forever. But for you, it's a one-way trip into the unknown. Get close enough, and the tidal forces, the difference in gravity between your feet and your head, becomes so extreme, you're stretched into a thin filament of matter. Spaghettification. That's the real word. It's not science fiction. It's astrophysics. And then, you're gone. No one knows what happens next. Maybe you're crushed into the singularity. Maybe you slip into another universe. Maybe you're encoded on the event horizon, forever part of the black hole's memory. And that's just the regular kind. There are supermassive black holes. Primordial black holes. Theoretical monsters called ultramassive black holes, millions of times heavier than even the largest known ones. And then there's the possibility of rotating black holes, which might twist spacetime into loops. Or wormholes. Or time machines. Or gateways to oblivion. Whatever they are, black holes are the endgame. The final frontier of fear. Just when you think the universe couldn't get any deadlier, it does. You've seen neutron stars and black holes. You've marveled, or trembled, at quasars. But what if I told you there's something even faster, even more explosive, something that doesn't just kill planets, it erases them from history? Enter, gamma ray bursts. These are the cosmic snipers. Silent, sudden, and devastating beyond belief. They don't last long, sometimes just a few seconds, but in that time, they release more energy than our sun will emit in its entire 10 billion year lifetime. Let that sink in. 10 billion years, condensed into 10 seconds. So what causes them? Most gamma-ray bursts, or GRBs, for short, are born from collapsing hypergiant stars. These monsters are dozens of times the mass of our sun. When they run out of nuclear fuel, their cores implode and form black holes almost instantly. But here's the twist: as the outer layers collapse, powerful magnetic fields funnel the explosion into narrow jets that burst out of the star's poles, beams of pure gamma radiation moving at nearly the speed of light. If one of those beams is pointed at you, game over. Doesn't matter if you're light years away. The radiation fries atmospheres, shreds DNA, and can trigger extinction-level events. In fact, some scientists think a GRB may have caused one of Earth's mass extinctions millions of years ago. Just imagine that, a silent death ray from across the galaxy wiping out life like flipping a cosmic switch. You wouldn't see it coming. You wouldn't even feel it. The burst would strip away the ozone layer, flood the surface with ultraviolet radiation, and scorch everything alive, all in a matter of minutes. And that's just one kind of GRB. There are others, created when two neutron stars collide. A dance of death billions of years in the making. As they spiral toward each other, they release gravitational waves, ripples in spacetime itself. And when they finally merge, the resulting explosion births a black hole, and a gamma-ray burst so powerful, it could sterilize an entire section of a galaxy. Gamma-ray bursts are not rare. We detect them all the time, from distant galaxies, long gone. The only reason Earth is still here. Dumb luck. No burst has ever been aimed directly at us. Yet. Now take a breath, because it's about to get even stranger. Let's talk about strange matter, one of the most bizarre and potentially lethal concepts in modern physics. It's hypothetical. But not fantasy. Imagine this: deep inside some neutron stars, under unimaginable pressure, protons and neutrons are crushed into something even more exotic, quarks. And under the right conditions, those quarks could form a new state of matter. Something stable, heavy, and incredibly dense, strange matter. Here's where it gets terrifying. Strange matter might be contagious. If even a single chunk of strange matter, what scientists call a strangelet, came into contact with ordinary matter, it could trigger a chain reaction. Atom by atom, it would convert normal matter into more strange matter. Like a virus for the building blocks of the universe. Theoretically, if a strangelet ever touched the Earth, it could turn the entire planet into a lifeless, superdense ball of strange quark goo in seconds. No explosion. No sound. Just a quiet end. No one knows if strangelets exist. But the fact that we can even model them, that we can imagine such a possibility, is a reminder: the universe isn't obligated to make sense to us. It just is. And now, from theoretical nightmares to something more subtle, more insidious. You've probably never feared a planet. After all, we live on one. Planets are solid. Predictable. Familiar. But out in the void, drifting through interstellar space, are rogue planets. Worlds without suns. Abandoned. Forgotten. And utterly invisible. These cosmic orphans are terrifying not because they explode, or radiate, or burn. They kill through silence. Through collision. Imagine a gas giant, larger than Jupiter, moving at tens of kilometers per second, completely undetectable in the dark. No light. No warning. Just cold, massive momentum. If a rogue planet wandered into our solar system, it could wreak gravitational chaos. Planets thrown from orbits. Tides rising. Temperatures falling. And if it slammed into Earth? It would release energy equivalent to millions of nuclear bombs, enough to boil oceans and crack the crust wide open. And the kicker? There could be billions of rogue planets in the Milky Way. Maybe more. Formed in violent star systems and flung into the dark. Or maybe, created by civilizations long gone. Abandoned Dyson spheres. Engineered planets lost in time. We don't know. And we may never know, until one comes knocking. Still breathing? Good. Because we're almost at the end. But there's one last contender for the deadliest thing in the universe. Something that hides in plain sight. Something so fundamental, so ordinary, we almost forget how lethal it really is. Antimatter. Yes, antimatter. The mirror twin of regular matter. Every particle we know, electrons, protons, neutrons, has an antimatter counterpart. Same mass, opposite charge. And when the two meet? Annihilation. Pure energy. No residue. No smoke. Just, gone. When matter and antimatter collide, they don't just explode. They convert into gamma radiation. 100% efficiency. No waste. A single gram of antimatter, meeting 1 gram of matter, releases the same amount of energy as 43 kilotons of TNT, that's 3 times the Hiroshima bomb. From 1 gram. Now imagine a whole planet made of antimatter. If it ever touched Earth, even a fragment, it would unleash a chain reaction of annihilation so fast, so intense, it could rival a small star. Everything near the impact point would be vaporized in microseconds. Thankfully, the universe seems to be overwhelmingly made of regular matter. Why antimatter vanished after the Big Bang is still one of the great mysteries of physics. But we know it's out there. We've created it in labs. We've seen it in cosmic rays. It exists. And if somewhere, somehow, there's a cloud, a comet, or a civilization playing with antimatter, we may one day see its fury up close. So here we are, standing on the edge of human understanding. We've looked into the heart of dying stars, stared down the barrel of gamma-ray bursts, wandered through the shadows of rogue planets, and imagined the annihilation of all we know in a single flash of antimatter. And yet, the universe is still not done with us. Because the most terrifying truth of all, we've only scratched the surface. The cosmos is a cathedral of extremes, of fire and ice, silence and fury, time and timelessness. And we, tiny creatures clinging to a fragile rock, have dared to open the doors and peek inside. What we found is not a gentle universe. It's not built for us. It doesn't care about us. It was not designed for comfort, or life, or even permanence. It is, at its core, a machine of chaos, beautiful, yes, but indifferent. And in that chaos are patterns. And in those patterns, danger. But don't let that paralyze you. Let it electrify you. Because despite the supernovae and singularities, despite the planets that wander and the matter that devours itself, you are here. Conscious. Alive. Capable of knowing this universe that threatens to unmake you at every turn. That, in itself, is a kind of miracle. You're made of atoms that were forged in the hearts of stars. You think with particles that once danced in the fire of the Big Bang. And now, you sit, maybe in your room, maybe on a train, maybe under the stars, and you wonder. You listen. You imagine. You look death in the face, written in the language of astrophysics, and instead of turning away, you lean in. This is what makes us explorers. The universe is deadly, yes. But it's also the greatest story ever told, written in light and gravity and time. Every black hole is a question. Every gamma burst, a warning. Every rogue planet, a riddle in the dark. And we are the only species we know of that dares to ask what it all means. So don't be afraid of the deadliest things in the universe. Be curious. Be bold. Because the stars that kill, are also the stars that made you. And the more we understand them, their rage, their silence, their cold logic, the more we understand ourselves. The universe is vast. It is violent. It is unforgiving. But it is also yours to discover.
Imagine peering deep into the darkness of space and seeing the past. Not yesterday, not last year, but billions of years ago. That's the magic of light in the cosmos. It travels, slowly, patiently, stubbornly, and some of it began its journey before our sun was even born, before Earth had a name, before atoms on this planet had ever thought of becoming human. In space, distance is time. The farther we look, the older the universe appears. And when we talk about the oldest objects ever discovered, we're not just dusting off cosmic antiques. We're touching the cradle of time itself. These are relics from when the universe was still wiping the Big Bang from its eyes. Let's start with a bang. Literally, the cosmic microwave background. It's not an object you can hold, but it's the first light that ever existed. A whisper from when the universe was just 380,000 years old. If the universe were a 100-year-old person, this light comes from its first few hours of life. It's not just old, it's primordial. It blankets the cosmos like an invisible aura, a baby picture of everything. Now fast forward to galaxy GN-Z11. Spotted by the Hubble Space Telescope, this little smudge is over 13.4 billion light-years away. That means the light we're seeing left this galaxy when the universe was only a few 100 million years old. That's cosmic infancy. Think about it. When GN-Z11 released its photons, not a single planet in our solar system existed. Not even the atoms that would one day become Earth were assembled yet. But wait, there's more. Enter HD 140283, also known as the Methuselah star. Astronomers named it after the oldest man in the Bible, and for good reason. This star is estimated to be about 14.5 billion years old. Yes, you heard that right. That's older than the universe itself, at least based on some measurements. Of course, there's a margin of error, but still, when your age challenges the timeline of reality, you're kind of a big deal. Then we find ourselves face to face with ancient black holes. Quasar J 0313-1806 is the oldest and most massive quasar we've ever discovered. It dates back to just 670 million years after the Big Bang. And yet, it's already powered by a black hole 1.6 billion times the mass of the Sun. How? How did something so massive form so fast? The laws of physics shrug and look away. This is cosmic mystery at its finest. Drifting nearby in the Gallery of Ancients is Galaxy Max 1149-JD1. It was spotted using a combination of Hubble and the mighty ALMA observatory. Its light has been traveling for 13.3 billion years. What's even more surprising is that scientists found signs of star formation in this galaxy that began just 250 million years after the Big Bang. That means the first stars were igniting while the universe was still stretching its arms and learning to breathe. And then, like cosmic elders in a vast, dark cathedral, we meet globular clusters. These dense balls of ancient stars orbit galaxies, like bees around a hive. Some of them, like M4 and NG C6397, harbor stars that are over 13 billion years old. They're survivors of an age when galaxies were barely more than smudges, and they're still here, glowing faintly like embers from a fire that began before time could count. Let's not forget the mysterious zinc-poor star, SMSS J03130.36-6708339.3. It doesn't have a catchy nickname, but it's one of the oldest known stars in the Milky Way halo. Estimated at 13.6 billion years, this ancient beacon likely formed from the remains of the very first stars so massive they lived fast, died young, and exploded in the first great fireworks show the universe had ever seen. Some of the oldest materials aren't floating in space at all. They're right beneath our feet. Pre-solar grains found inside meteorites on Earth are tiny fragments of stardust that predate our solar system. Some are over 7 billion years old. They drifted through interstellar space long before our sun took its first breath. And somehow, against all odds, they found their way to Earth and into our hands. And then there's the human mind. Yes, you heard me. Because while the objects we're talking about are ancient, the act of discovering them is profoundly modern. We're not just observing the past, we're decoding it, we're reconstructing it. Every telescope we launch is a time machine. Every photon caught is a story told. There's something deeply poetic about ancient starlight. It doesn't age in flight. The light you see from a galaxy billions of years away isn't tired. It isn't worn out. It's fresh. It's now. As if the universe held onto it for eons just to deliver it to your retina at the right moment. So the next time you gaze into the night sky, remember this. You're not just looking into space. You're looking into history. You're staring into the hearts of stars that lived, burned, and died before your species had language, before your planet had oceans, before there was a you to do the looking. And yet, here you are, thinking about it, wondering, reaching, not just with telescopes, but with curiosity. That's what makes ancient starlight matter. Not just what it shows us about the past, but what it tells us about ourselves. So what does it mean that we can see so far? That our technology can reach back almost to the beginning of time? It means we're not just passengers in this universe. We're witnesses, chroniclers, detectives uncovering the ancient narrative of creation, one photon at a time. And what's more, those ancient photons don't care who you are. They don't care about your language, your nation, your politics. They land equally in the eyes of everyone under the night sky. They are democratic in the truest sense, a universal inheritance. This light, older than every mountain, every continent, every civilization, is free. It has crossed the abyss of time, not to dazzle us, but to inform us, to whisper truths that no scroll or tablet ever recorded. A kind of cosmic honesty, born of fusion, gravity, and time. And if you really think about it, you and I, we are made of the same stardust that once blazed in those ancient stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, it was all forged in the death throes of stars that lived and died before the Earth existed. You are not merely in the universe is in you. That connection isn't poetic fluff. It's physics, it's chemistry, it's truth, and it should stir something primal in every thinking mind. The universe doesn't just speak in explosions and gravity wells. Sometimes it speaks in silence, in faint glimmers from the edges of time. And when we learn to listen, really listen, we begin to understand that the story of ancient starlight is also the story of us. A story still unfolding. A story still being written in the sky, right now. And guess what? You're part of it.
Top 7 stars that shouldn't exist. The universe, in all its vastness, operates with rules. Gravity, fusion, entropy, laws that stretch across billions of light years, written into the very code of reality. And yet, every so often, we find something that breaks those rules. Something that shouldn't exist. Something that laughs in the face of physics and says, "Try explaining this." Today, we're not talking about ordinary stars. Not your run-of-the-mill balls of plasma burning hydrogen like cosmic fireplaces. No. We're talking about the rebels. The freaks. The ones that make scientists scratch their heads and question everything we thought we knew about how the cosmos works. Let's begin with one of the strangest offenders, HD 140283, also known as the Methuselah star. Located just 190 light-years from Earth, it looks pretty ordinary. But when astronomers calculated its age, their jaws hit the floor. This star appears to be 14.5 billion years old. That's older than the universe itself. You heard that right, older than the Big Bang, which happened about 13.8 billion years ago. How is that possible? Now, of course, the universe didn't break its own clock. More likely, it means that something in our models is off, maybe the measurements, maybe the assumptions, maybe the star formed from primordial material left over from the Big Bang in a way we don't yet understand. But still, imagine finding a passport that says someone was born before time itself. That's HD 140283. It sits there, defying logic, challenging cosmology, and looking completely unbothered. And then there's our 136A1, the heavyweight champion of the cosmos. Located in the Tarantula Nebula, inside the Large Magellanic Cloud, this star is a monster. It's more than 250 times the mass of the Sun, and it shines nearly 9 million times brighter. According to our best theories, stars this big shouldn't exist. The forces trying to blow it apart should overpower the gravity holding it together. And yet, there it is. A beast of burning gas so luminous, it could strip the atmospheres off planets from light years away. Its life will be short, maybe just a few million years, but it will end in a supernova so powerful, it could leave behind a black hole big enough to swallow a star cluster. Our 136A1 isn't just a star. It's a cosmic furnace pushed to the absolute edge of what physics can handle. Now let's travel to the opposite extreme, to a star that's not big, but dense beyond reason, PSRJ 1748-2446A. This one doesn't shine brightly. It doesn't blaze across space like a quasar. It just spins. And spins. And spins. This is a pulsar, the collapsed core of a dead star, a neutron star, and it's rotating 716 times per second. That's faster than a kitchen blender. Faster than a helicopter blade. Faster than anything that massive should be able to spin without tearing itself apart. It completes one full rotation in just 1.4 milliseconds. Try to picture it. A city-sized ball of ultra-dense matter, heavier than the Sun, rotating hundreds of times per second, emitting radio pulses with the precision of an atomic clock. If it spun just a bit faster, the centrifugal force would overcome gravity, and it would explode outward. But somehow, it doesn't. Somehow, it holds. And it shouldn't. Then there's HV 2112, a star that might contain elements that don't belong inside stars. This strange giant, located in the small Magellanic Cloud, shows spectral lines of molybdenum, rubidium, and even lithium, elements that typically form in completely different environments. For years, scientists didn't know how to classify it. It didn't fit. It looked like a red supergiant, but with chemical fingerprints that didn't match anything we've seen before. One theory: HV 2112 might be the first example of a Thorne-Zitko object, a theoretical star formed when a neutron star merges into the core of a red supergiant. A star within a star. A cosmic Russian nesting doll made of fire and nuclear madness. We're still not 100% sure. But if that's what it is, it shouldn't exist. It's like finding a black hole inside a candle. Let's turn now to SMSSJ031300.36-6708339.3, don't worry, we'll just call it J03. This ancient relic, floating in the halo of the Milky Way, may be one of the first stars ever born after the Big Bang. But here's the kicker: it has almost no iron in its composition. That might sound trivial, but it's huge. You see, stars are born from the remains of older stars. Every time a star dies, it enriches the cosmos with heavier elements. So the next generation should contain more metals. But J03 has almost nothing but hydrogen and helium, just a whisper of the heavier stuff. It suggests this star formed in a universe barely out of the womb, before supernovae had a chance to seed the cosmos. It's a ghost. A time traveler. A living fossil of the ancient universe, drifting quietly through space, telling us stories older than Earth itself. And the fact that it's still burning, still shining after all this time, that breaks everything we thought we knew about stellar lifespans. But perhaps no star breaks our brains more than KIC 846-2852, also known as Tabby's star. Located about 1,470 light-years away, Tabby's star made headlines when astronomers noticed it dimming in bizarre, unpredictable patterns. Not once. Not twice. But dozens of times, by up to 20% of its total brightness. That's not just a planet passing in front. That's something else. No natural explanation quite fits. Dust clouds? Maybe. Swarms of comets? Unlikely. Colliding moons? The wildest theory, and the one that captured public imagination, was this: a megastructure. A Dyson swarm. An alien civilization building a star-sized solar power station. Is it aliens? Probably not. Is it weird? Absolutely. Tabby's star doesn't behave like any other star we've ever observed. And the fact that we still don't have a solid explanation, that's both terrifying and exhilarating. Still think we've seen it all. The universe is just getting started. Let's shift gears and meet a star so cold, it challenges our very definition of what a star even is, WISE 0855-0714. Technically, it's a brown dwarf, the awkward middle child between stars and planets. Too big to be a planet, too small to sustain hydrogen fusion like a proper star. But what makes WISE 0855 so absurd is its temperature. This object has a surface temperature of around -13 degrees Celsius 8 degrees Fahrenheit. That's colder than your freezer. That's cold enough for clouds of water and ammonia to form in its atmosphere, clouds made of ice, not plasma. A star with clouds. A star that could, in theory, snow. And it's only 7 light-years away. In our backyard. Barely glowing. Barely radiating. But somehow massive enough to be called a substellar object. It shouldn't exist by standard models. But there it is, floating silently in the interstellar dark, a ghost of a failed star, chilling in every sense of the word. Now let's flip that idea on its head. Enter Mira A and Mira B, a binary system that looks ordinary at first glance. Mira A is a pulsating red giant, and Mira B, well, that's where things get spicy. Mira B is likely a white dwarf, a remnant core of a dead star. But what's bizarre is how Mira A sheds its outer layers, and Mira B sucks them up, forming a disk of material around itself. It's stellar cannibalism. A cosmic love story turned horror movie. This feeding frenzy has gone on for centuries, possibly longer. It's like watching the end of a star's life become fuel for another, a bizarre recycling program of fusion and decay. And what's more baffling is that Mira A is racing through the galaxy, leaving behind a trail of glowing gas stretching 13 light-years long. It's like a comet tail, except the comet is a star. Nothing in our textbooks said this should happen. Nothing said stars should leave behind glowing stellar contrails across the galaxy. But Mira does. Now let's talk about a star that is, quite literally, made of diamonds. Yes, really. Meet PSR J2222-0137. It's a white dwarf. But not just any white dwarf, it's an ultramassive one, composed mostly of carbon and oxygen, compressed so tightly that much of it has crystallized. That's right. This dead star, once larger than our Sun, has cooled and solidified into a crystal sphere the size of Earth. A diamond star. A literal cosmic gem, shining faintly in the void. In fact, astronomers believe some white dwarfs in our galaxy have been cooling for so long, they've completely crystallized inside. Imagine holding a diamond, billions of carats wide, drifting through space. It's one of the most poetic contradictions in nature, a thing born of death, collapsing into beauty. But it also raises questions. How common is this? How many jewel stars are out there, twinkling invisibly in the dark? And could these objects represent a final stage of matter, stars that have turned into silent monuments of time? Now, we can't talk about impossible stars without visiting one of the strangest in the entire catalog, 2 Mass J0523-1403. It is the smallest known star capable of fusion. Just 8.6% the mass of the Sun, it barely squeaks past the threshold needed to sustain hydrogen fusion in its core. Any smaller, and it wouldn't be a star at all, just another brown dwarf. Its radius is only about 1/10 that of the Sun, and yet it manages to burn. Faintly. Quietly. Endlessly. It will likely outlive every other star in the galaxy, shining dimly for trillions of years. Why is it so weird? Because it's the lower boundary of stellar possibility. The absolute minimum mass needed to spark nuclear fire. The edge of stardom. And yet it exists, living proof that the line between planet and star is not a line at all, but a shimmering, mysterious gray zone. And finally, let's visit RZ Piscium, a star that's eating its own planets. This young, volatile star shows strange dimming patterns, like Tabby's star, but with a twist. Astronomers believe it's surrounded by a dense disk of gas and dust, not from the remnants of its birth, but from disrupted planetary material. That's right. RZ Piscium is likely tearing apart its own planets, shattering them through tidal forces, heating the fragments, and pulling them into its blazing atmosphere. Imagine entire worlds being pulled to pieces, swallowed by their parent star in a spiral of fiery doom. It's not just a star. It's a destroyer of worlds. A cosmic executioner. And it shouldn't exist. Because planetary systems are supposed to stabilize over time. Orbits settle. Gravity calms. But here, everything is still violent. Chaotic. Apocalyptic. It's a glimpse into the adolescence of stars, and a warning, not every system ends in peace. The more we explore the cosmos, the more we realize, the universe doesn't care about what should be. We make models. We draw charts. We calculate boundaries and build equations that describe how stars are born, how they live, and how they die. But again and again, the stars surprise us. They refuse to fit into our neat little boxes. From ancient stars that seem to predate the universe, to massive giants that shouldn't be able to hold themselves together, from frozen failures that pretend to be stars, to diamonds adrift in the dark, each of them tells the same story: we don't know everything. We like to believe we've got this universe mostly figured out, gravity here, fusion there, a pinch of dark matter to spice things up. But then the cosmos throws us a curveball. A star that spins too fast. A system that eats its own planets. A fossil of the early universe still burning billions of years later. And what do? We investigate. We revise. We learn. Because that's what science is, not a list of answers, but a process of curiosity. A willingness to be humbled by the impossible. These stars, the misfits, the monsters, the mysteries, they remind us that the universe is still wild. Still strange. Still full of secrets waiting to be uncovered. And isn't that what makes it all so beautiful? Because beyond the numbers, beyond the theories, beyond the telescopes and satellites and simulations, there's wonder. That childlike sense of awe when you realize that somewhere out there, in the cold black silence of space, a diamond the size of Earth is spinning, a zombie star is pulsing like a beacon, and a newborn sun is tearing its own planets apart. These aren't just astrophysical curiosities. They are poetry. They are defiance. They are proof that the universe is more imaginative than we are. And while these stars may not make sense on paper, they exist. They burn. They whisper, across light years of emptiness, you have no idea what's really out here. And that's why we keep looking up.
Imagine setting out on a cosmic journey, fueled by wonder, curiosity, and just a hint of madness. The universe is vast and beautiful, but it's also a place of unimaginable dangers. If you think a shark-filled ocean is terrifying, just wait until you see what the cosmos has cooked up. So buckle up, traveler. Today, we venture into the top 5 most dangerous places in the universe to visit. First stop, the surface of a neutron star. Picture this, a city-sized sphere, packing more mass than our entire sun, crushing atoms until they become an ocean of neutrons. Step foot here, if that were even possible, and you'd be flattened instantly by gravity 2 billion times stronger than Earth's. Forget hiking boots, you'd need quantum armor, just to survive the first nanosecond. Time, space, and even the definition of matter itself twists under such pressure. Here, reality bends, and the line between science and science fiction blurs. Next, we drift toward the center of a supermassive black hole. It sounds poetic, spiraling into a cosmic ballet of darkness, but in truth, it's pure annihilation. As you approach, tidal forces stretch you thinner and thinner until you become a single strand of atoms, a phenomenon chillingly named spaghettification. No spaceship, no shield, no desperate scream can save you. You wouldn't even see it coming. The very light carrying the warning signs is swallowed whole, lost to eternity. Crossing the event horizon is a one-way ticket, and no postcards from the other side. Now, let's get adventurous. How about visiting the Buddha's Void? Sounds harmless, right? Wrong. Imagine a region of space so empty, so utterly devoid of stars, galaxies, and light, that it stretches nearly 330 million light-years across, like a cosmic ghost town. Travel here, and you'd find yourself in a cosmic silence so deep, your mind might fracture under the sheer psychological weight. No light, no stars, no beacons to guide you home. Just endless, suffocating darkness, whispering into the folds of your sanity. Feeling brave? Good, because now we're heading to the gamma-ray burst zone. Somewhere out there, massive stars are dying in violent explosions, releasing more energy in a few seconds than our sun will produce over its entire 10 billion-year lifetime. If you happen to be anywhere nearby, and by nearby, I mean hundreds of light-years away, the radiation would incinerate your spacecraft, strip away your atmosphere, and cook your DNA like overdone bacon. You wouldn't even have time to register the flash. You'd simply cease to exist, erased by a silent cosmic bullet traveling at the speed of light. And finally, the crown jewel of cosmic nightmares, the quasar's heart. Imagine a black hole so ravenous that, as it devours entire stars, it spews jets of radiation millions of light-years into space. A quasar's core shines brighter than entire galaxies combined, but approach too close, and you're caught in a maelstrom of lethal particles and magnetic storms. Here, physics goes feral. Gravity becomes a tyrant. Light itself struggles to escape the chaos. Visiting a quasar's core would be like flying into the mouth of an angry god, a blinding fury of energy, soundless but merciless. The universe is breathtaking, yes, but it is also merciless in its indifference. Beauty and terror, intertwined like twin strands of DNA, stitched into the very fabric of existence. And while we gaze up in awe, safely tucked away on our pale blue dot, these cosmic monsters lie in wait, silent, patient, eternal. But danger in the universe isn't always about brute force or cosmic violence. Sometimes it's about environments so alien, so extreme, that they defy the very rules life depends on. Take the atmosphere of a hot Jupiter, giant exoplanets that orbit scorchingly close to their stars. Here, temperatures soar to thousands of degrees, and winds scream at speeds of over 5,000 miles per hour. Iron doesn't just melt, it vaporizes, forming metallic clouds that rain molten droplets from the skies. Imagine standing on a world where the storm clouds aren't water, they're boiling metals, and every breath would ignite your lungs. Even machines wouldn't survive more than a few seconds in that hellish cauldron. Or consider the core of a white dwarf, the smoldering skeleton of a dead star. If you could somehow dig down into this cosmic ember, you'd find something truly bizarre. A mass of crystallized carbon and oxygen, essentially a gigantic diamond floating in space. But don't let its sparkle fool you. The gravitational forces here are so intense that a teaspoon of white dwarf material would weigh as much as a skyscraper. Its beauty forged under unimaginable pressure, a jewel crafted by death itself. Now, imagine venturing into the magnetosphere of a magnetar, the magnetic monster cousins of neutron stars. A magnetar's magnetic field is 1 trillion times stronger than Earth's. Get too close, and it could tear apart the very atoms that make up your body. Not your ship, not your suit, your atoms. It's like nature reached deep into its bag of tricks and pulled out a force so powerful it breaks the rules of matter itself. Just being nearby would scramble your brain's electrical signals before you even knew you were in trouble. And then there's the accretion disk of a black hole, the swirling halo of gas and dust spiraling into oblivion. Temperatures here can rival the cores of stars. The friction alone produces radiation so intense it could sterilize entire regions of space. You wouldn't even need to fall into the black hole to be doomed. Just brushing the edge of its hungry whirlpool would be enough to reduce a spacecraft to its component atoms, scattering them across the event horizon like cosmic confetti. Finally, we can't forget the raw chaos of star-forming nebulae. From a distance, they look majestic, colorful clouds of dust and gas where new stars are born. But inside, it's a battlefield of radiation, shockwaves, and gravity so turbulent that entire planetary systems can be shredded before they even form. Here, destruction and creation dance hand in hand. Step into this cosmic nursery without proper shielding, and the high-energy particles would slice through you like 1,000 invisible knives. Its beauty in its most violent infancy. The universe doesn't hide its dangers behind locked doors. It puts them on full display, dressed in dazzling lights and spectacular phenomena, daring the bold and the curious to come closer. It's a place where survival isn't guaranteed, where the rules you trust to keep you safe are bent, broken, and sometimes erased entirely. Yet despite all of this, despite the peril, the chaos, the unimaginable extremes, we can't look away. Because in every fiery death, Every crushing force, every storm of annihilation. The universe reminds us of something profound, that existence itself is a miracle carved from the very heart of chaos. And what about the places where even time itself seems to lose meaning? Imagine wandering too close to the edge of a cosmic string, hypothetical one-dimensional defects in space-time, thinner than an atom, but heavier than a mountain range. Their gravitational pull would be so intense that they could warp space around them like a tornado twisting the sky. One accidental crossing, and you might be hurled across the galaxy, or torn out of existence before you even realized it. Then there's the chaotic realm of colliding galaxies. Two titanic cities of stars, each containing hundreds of billions of suns, smashing together over hundreds of millions of years. It's not just a fireworks show. Gravitational forces rip apart solar systems, black holes spiral toward inevitable confrontation, and radiation storms sweep through the interstellar medium. If you were unlucky enough to be caught in the chaos, no amount of shielding or evasive maneuvering would save you. It would be like trying to survive a demolition derby where every car weighs 1 trillion tons, or dive into the deadly drama of a Type Ia supernova, the ultimate cosmic bomb. When a white dwarf siphons off just enough material from a companion star, it crosses a critical mass limit and detonates in a thermonuclear explosion that can outshine entire galaxies. If your spacecraft were parked nearby, the flood of gamma rays would strip away your protective layers, cook you alive in milliseconds, and erase all traces of your visit. Not even light can outrun the sheer devastation. And lurking in the dark, hidden by shadows, are rogue planets, giant orphan worlds ejected from their parent stars, drifting alone through the void. Their surfaces are frozen, their skies eternally black. No sun, no warmth, no life, just endless night and lethal cold that would sap every last joule of heat from your body until you became a frozen relic, preserved for eternity in a universe that wouldn't even notice you were gone. But perhaps the most chilling threat is something subtler: vacuum decay, a nightmare straight from quantum physics. If our universe exists in a false vacuum, a precarious, unstable state, then somewhere, at any moment, a tiny bubble of true vacuum could spontaneously form and expand at the speed of light. Anything it touches would be wiped clean. Atoms, stars, galaxies, the very laws of physics rewritten. There would be no warning, no escape, no trace. Reality itself would be reprogrammed. The universe is not just a place of wonders. It's a crucible of extremes, where survival is the exception, not the rule. Every sparkling nebula, every swirling black hole, every lonely rogue planet is a chapter in a cosmic story written in the language of creation and destruction. And somehow, against all odds, on one tiny rock orbiting a modest star, life found a foothold and dared to look up. Here at Whispers of the Cosmos, we don't just stare into the night sky. We listen. We listen to the silent roars of black holes, to the echoes of ancient stars, to the deep resonant hum of a universe both terrifying and breathtaking. Every whisper from the cosmos tells a story of danger, of beauty, of endless possibility. And as long as there are mysteries in the sky, we'll be here, listening, wondering, and reaching ever further into the infinite. But let's step back and ponder for a moment. A galactic collision isn't merely an isolated cosmic incident. It's part of a universal dance happening everywhere we look. Across billions of years and billions of galaxies, Collisions have continually shaped and reshaped our universe, sculpting galaxies into new forms, sparking cascades of star birth, and enriching the cosmos with new generations of planets and possibly even life. Take, for example, the stunning Antennae galaxies, a cosmic embrace frozen in time. These two galaxies, located millions of light years away, are right now engaged in a spectacular gravitational battle, their spiral arms entangled like interstellar lovers locked in an endless dance. Their collision sets off bursts of stellar fireworks, lighting the universe with intense flashes of newborn stars. It's a visual symphony of destruction and creation, a testament to the unstoppable power of gravitational attraction. And there's Centaurus A, one of the nearest galactic collisions to our own Milky Way. It's an elliptical galaxy devouring a smaller spiral, leaving a chaotic, dust-filled scar stretching across its luminous core. Centaurus A is a reminder that even serene-looking galaxies have tumultuous pasts, their present forms often hiding violent histories beneath a calm exterior. When galaxies merge, something truly profound happens, an extraordinary reshuffling of cosmic material. Massive gas clouds collide, collapse, and ignite into spectacular star-forming regions. Bright clusters of new stars illuminate these galaxies like cosmic cities suddenly bursting to life. In those intense nurseries of stellar birth, the elements essential for life itself, carbon, oxygen, nitrogen, are forged and scattered throughout space, eventually seeding new worlds. In fact, you and I, we're children of these cosmic collisions. Every atom in our bodies, carbon in our cells, iron in our blood, calcium in our bones, was once cooked in the heart of distant stars, dispersed in supernovae explosions, and carried across galaxies by the chaos of collisions. We are quite literally star stuff, reborn from the ashes of cosmic encounters. But what's perhaps most astonishing is that these cosmic collisions aren't rare. They're routine. They are the heartbeat of the universe, occurring countless times throughout cosmic history. Even now, somewhere across the vast expanse of the cosmos, galaxies are colliding, stars are igniting, and new worlds are forming, potentially worlds teeming with life. Yet there's a haunting beauty to this perpetual transformation. Consider the Sombrero Galaxy, majestic, elegant, a radiant swirl of stars encircled by a graceful ring of dust. This peaceful appearance belies a violent past. Its perfect symmetry was likely forged by collisions with smaller galaxies, each one adding new layers of stars and dust, ultimately sculpting a cosmic masterpiece. And then we look further still, billions of years from now. After Milky settles into its new form, the night sky, viewed from a distant future Earth, if Earth still harbors life, would be unrecognizable. The peaceful, star-studded tapestry we see today, replaced by luminous arcs of stellar material, vast nebulae glowing brilliantly, clusters of new suns illuminating skies no human has yet imagined. It would be a cosmos reborn, transformed by forces grander and older than humanity itself. This constant collision and reshaping of galaxies serve as a powerful reminder. Nothing in the universe is permanent. Stars ignite and fade, galaxies merge and reform, planets evolve, life emerges, thrives, and sometimes disappears. This is the fundamental truth of existence: change, growth, transformation, constant motion, driven by the universal laws of physics and gravity. And perhaps that's what makes these galactic collisions so deeply fascinating. They illustrate nature's astonishing creativity, its endless capacity for renewal and reinvention. Within cosmic destruction, lies the seeds of new creation. Within chaos emerges stunning order, and within universal upheaval lie the conditions for life's continual rebirth. So as we stand on this tiny blue planet, gazing into the infinite expanse above, we witness more than stars and galaxies. We see a dynamic universe in perpetual motion, revealing itself through collisions and mergers that shape not just galaxies, but life itself. Whispers of the cosmos. Imagine gazing into the vastness of space and seeing ghostly shapes drifting silently, their ethereal tendrils stretching out across millions of miles, illuminated by the faint glow of newborn stars or the fading embers of dying suns. These are cosmic ghosts, the mysterious nebulae that fill our universe with awe, wonder, and questions that challenge the very essence of human understanding. Today, we venture deep into the cosmos, exploring 7 of the most enigmatic, eerie, and extraordinary nebulae ever discovered. Buckle up, cosmic explorers. It's time to chase some ghosts. We start our journey in the heart of Orion, a stellar nursery known as the Orion Nebula, a cosmic cradle that dazzles astronomers and dreamers alike. Visible to the naked eye on clear nights, Orion's cloud of glowing gas spans more than 24 light-years and cradles within it thousands of newborn stars. This nebula is a bustling cosmic maternity ward, where gravity pulls immense clouds of gas together until nuclear fusion ignites, birthing stars that shine with youthful vigor. The swirling, vibrant colors, crimson reds, sapphire blues, and shimmering greens, are not just visually stunning. They're signatures of hydrogen, oxygen, and other elements, painting a luminous portrait of cosmic creation. But the true mystery of Orion lies in its hidden depths, where strange, embryonic star systems form in dark pockets, hinting at the astonishing possibilities of life elsewhere. Next, drifting across the sky like a ghostly phantom, is the Horsehead Nebula, an iconic dark nebula silhouetted dramatically against a glowing backdrop of hydrogen gas. Located in Orion's belt, the Horsehead Nebula resembles a cosmic shadow, dark dust obscuring the brilliance behind it. This nebula is not illuminated from within, but rather sculpted by nearby stars, whose ultraviolet radiation carves and shapes its unmistakable silhouette. Imagine standing close by, gazing up at this towering column of cosmic dust, a dark sentinel tens of trillions of kilometers tall, silent, enigmatic, and shrouded in mystery. Inside this cosmic cloud, hidden from our sight, stars quietly form, protected by dense darkness that keeps their birth a tantalizing secret. But if the Horsehead is a silhouette of darkness, the Helix Nebula is the universe's haunting eye. Known as the Eye of God, it stares back at humanity from 700 light-years away, a glowing ring of gas surrounding the fading core of a dying star. This cosmic eye formed when a star, not unlike our Sun, reached the end of its life and gently shed its outer layers into space, creating this mesmerizing ring. Look closely and you'll see delicate filaments, cosmic eyelashes stretching outward, sculpted by stellar winds. The Helix Nebula serves as a chilling yet beautiful reminder of the future awaiting our own solar system, as stars inevitably age and fade, leaving behind ghostly remnants to captivate future observers. Then there's the Crab Nebula, a violently beautiful remnant born from a supernova explosion observed nearly 1,000 years ago by astronomers on Earth. In 1054, this cosmic explosion lit our skies so brightly that it could be seen even in broad daylight, recorded by ancient civilizations around the globe. Today, what remains is a swirling, turbulent cloud of energized gas and dust expanding at dizzying speeds. At its center pulses a rapidly spinning neutron star, a pulsar rotating 30 times each second, sending beams of radiation across the galaxy like a cosmic lighthouse. The Crab Nebula is an astronomical puzzle, constantly studied yet never fully understood, a testament to the immense power and mystery of stellar death. Moving farther into the cosmic realm, we find the Pillars of Creation, a breathtaking formation deep within the Eagle Nebula. These towering pillars, stretching several light-years tall, are clouds of gas and dust eroded by intense radiation from nearby young stars. Within these pillars lie hidden pockets, dark cocoons, sheltering newborn stars that someday will ignite, illuminating the nebula with new cosmic fire. The Pillars of Creation challenge our imagination, as their scale dwarfs human comprehension. If you traveled at the speed of light, crossing just one pillar would take several years. Yet remarkably, recent observations hint these majestic structures may already be gone, destroyed by a distant supernova whose shockwave has yet to visibly reach us. Are we witnessing ghosts, cosmic echoes traveling through time, structures that exist now only as haunting memories? Traveling deeper still, we encounter the mysterious Boomerang Nebula, the coldest known place in the entire universe. This ghostly apparition floats 5,000 light-years away, and its core is astonishingly colder than the faint afterglow of the Big Bang itself, plunging to temperatures just above absolute zero. The Boomerang Nebula's chilling environment comes from gas, rapidly expanding away from a dying star, creating an environment so frigid it defies comprehension. Imagine a place colder than the background temperature of space itself, an impossibly cold ghost drifting silently through the cosmos, offering clues about how stars die and the strange, extreme conditions they create. And finally, we journey to one of the most mystifying of all nebulae, Sharpless 2-136, commonly known as the Ghost Nebula. Located in the constellation Cepheus, this dark nebula appears like a spectral apparition, a shadowy figure reaching out into space with arms of dust and gas, illuminated faintly by nearby stars. The Ghost Nebula's haunting appearance isn't merely an optical illusion. Its dust particles reflect and scatter starlight, creating subtle shades and ghostly forms. Inside its cold, dense core, stars quietly incubate in darkness, slowly forming over millions of years. This nebula stands as a testament to cosmic mystery itself. Shadows in the darkness, holding secrets about the birth and life of stars that we're only beginning to unravel. Every nebula we encounter tells a story of birth, death, transformation, and the profound mystery of our cosmic origins. These cosmic ghosts, drifting silently through space, are celestial storytellers, narrating tales older than humanity itself. They remind us that the universe, vast and filled with wonder, continually challenges our imagination and understanding. As we continue deeper into our cosmic voyage, we encounter the enigmatic Cat's Eye Nebula, a dazzling spectacle nearly 3,000 light-years away in the constellation Draco. This nebula doesn't just shine, it practically dazzles, revealing a complex structure that astronomers still struggle to fully decipher. With concentric shells, intricate loops, and swirling filaments of gas and dust radiating outward, the Cat's Eye Nebula offers a hypnotic glimpse into the turbulent life of a dying star. Its captivating patterns hint at chaotic pulsations and eruptions from the star's past, a ghostly record of stellar upheaval frozen in cosmic time. Then, drifting silently in the constellation Aquarius, we meet the Saturn Nebula, a nebula bearing an uncanny resemblance to the ringed planet Saturn. Yet unlike its planetary namesake, this nebula isn't composed of rock and ice, but glowing gases expelled violently from a dying star. Its central star, nearing the end of its existence, continues to cast away layers of gas that illuminate the darkness around it, creating luminous elliptical rings. Studying this stellar phantom reveals clues about the ultimate fate of stars like our own sun, spectral hints of what our distant future might look like, billions of years from now. Venturing onward, consider the hauntingly beautiful Red Rectangle Nebula, truly one of the universe's strangest sights. Located about 2,300 light-years away, it defies expectation by presenting a perfect geometric shape, something rarely found in nature. Its mesmerizing rectangular symmetry is created by twin cones of dust streaming outward from a central binary star system. Within its mysterious form, astronomers have detected unusual molecules, including complex hydrocarbons, the building blocks of life, floating freely in space. Imagine gazing upon this cosmic marvel, witnessing chemistry itself, floating silently among the stars, and pondering the profound implications for life elsewhere in the universe. Farther out, we encounter the peculiar Tarantula Nebula, one of the most massive and energetic star-forming regions ever observed. Nestled within the Large Magellanic Cloud, an entirely separate galaxy orbiting our Milky Way, this nebula is visible across millions of light-years, shining with such intensity it would cast clear shadows if placed as close to Earth as the Orion Nebula. Within this cosmic arachnid, clusters of giant blazing stars generate powerful winds and intense radiation, sculpting surrounding gases into intricate patterns of luminosity. Inside this celestial forge, stars are born at furious rates, setting cosmic records and challenging our very understanding of star formation itself. Let's not overlook the Eskimo Nebula, a cosmic vision resembling a face wrapped in a fur-lined parka, looking back at us from over 5,000 light-years away. Here, glowing gases surround a dying star, arranged into intricate filaments resembling the folds of a hood. Ultraviolet radiation from its aging star excites these gases, making them glow brilliantly in blues, greens, and reds. This celestial face staring through space serves as a captivating reminder that nebulae aren't merely chaotic clouds. They can take on uncanny, recognizable shapes, as if the universe itself is playing a whimsical game of cosmic Rorschach. Peering even further, we find ourselves face to face with the Butterfly Nebula, located 4,000 light-years away and shaped precisely like a pair of celestial wings. Scientists believe this mesmerizing symmetry is produced by a binary star system hidden at its core, spiraling together and ejecting stellar material at incredible speeds. Each wing of the butterfly extends across trillions of kilometers, illuminated brightly by ultraviolet radiation. Imagine watching this celestial insect spread its wings across space, a delicate balance of chaos and order, illuminating the immense power and elegance of stellar evolution. Next, picture the Ghost Head Nebula, its spectral appearance lurking in the southern skies of the Large Magellanic Cloud. Here, an immense region of intense star birth shapes the nebula into mysterious, ghostly patterns. The nebula contains massive stars, thousands of times brighter than our Sun, illuminating vast regions of space, sculpting gaseous clouds into eerie shapes that shift and evolve over cosmic time scales. Peering into this distant stellar nursery is like glimpsing the heartbeat of the universe. stars emerging, thriving, and illuminating the cosmic darkness in an endless cycle of birth and renewal. And what about the mysterious Egg Nebula, another cosmic wonder, glowing faintly in the constellation Cygnus? Within this compact nebula, a star is undergoing its final transformation, casting off shells of dust and gas that reflect its dimming light. Illuminated jets stream outward, piercing dense clouds of cosmic dust, producing bright beams radiating in multiple directions. Astronomers marvel at the Egg Nebula's unusual structure, wondering what stellar processes created such breathtakingly precise features. A question that challenges our theories and fuels ongoing cosmic mysteries. Finally, picture yourself gazing upon the elusive Medusa Nebula, named for the mythical creature with snakes for hair, floating quietly within the constellation Gemini. This ancient remnant of a star's death drifts silently, tendrils of gas twisting gracefully through space, creating a haunting, ethereal presence. Its soft glow arises from ionized hydrogen and oxygen atoms, illuminated gently by the fading star at its center. The Medusa Nebula invites us to ponder the fleeting beauty and haunting mystery of stellar life cycles, a cosmic reflection on the delicate balance between life and death among the stars. All these nebulae, each a cosmic phantom drifting through interstellar darkness, serve as powerful reminders of our universe's boundless creativity, complexity, and mystery. These ghostly visions teach us about stellar birth and death, cosmic chemistry, and the perpetual dance of matter and energy that shapes everything around us. Nebulae aren't just clouds of gas and dust. They're whispers of cosmic history, fragments of stories billions of years old, silently urging us onward in our endless quest to understand the universe that gave us life. Whispers of the cosmos.